Hello, hi, namaskar everyone. My name is Deependra and I welcome you all in this one short video of the chapter Binomial Theorem. This chapter is so vital in its sense that this chapter's concepts and learnings are used in other chapters as well. Whether it is the properties of binomial coefficients or the remainder theorem or last digit or maybe the integral or the fractional part. So yes, last year only JEE Mains has asked 23 questions cumulatively from this particular chapter only. Mainly or mostly moderate difficulty level of questions are asked from this chapter. So remember, if you learn all the concepts well, you can solve some questions from this chapter definitely. And this one shot is going to cover everything which you need to learn from this particular chapter as far as binomial theorem is considered. Do remember, we'll discuss the formulae, concepts, learnings, short techniques, and we'll consolidate all of these with the help of the previous year's questions. So everything is going to be covered at absolutely free of cost. I hope you remember it, that along with this video, we are also giving you these handwritten notes and the DPPs for your practice. These notes and DPPs are available on our PW app, the link to which is already given in the description. You can click on it and access this. PW app is an amazing platform from where millions of students are preparing for different competitive exams at affordable prices, and they're getting their desired results as well. So with that, without any delay, let us get started with this particular session. In this particular chapter, we'll start our discussion with binomial theorem. We'll discuss its expansion as well. And of course, we'll talk about the properties related to the binomial coefficients. Along with this, we'll talk about how do you deal with integral and fractional part based questions based on binomial theorem. Yes, there will be discussing multinomial theorem as well and properties, of course, and questions based on it. And then we'll come and talk about this part where we'll be discussing how to find the remainder, the last digit, the last two digits. And then we'll conclude our discussion with summation of series where you use differentiation and integration on binomial expansion and find summation of series. So this is all what we'll be covering and discussing in this particular one short video of binomial theorem. If I were to tell you that which are the two most important chunks where you should put most of your focus, then please understand these two topics: binomial theorem, its expansions, its basics, and how do you deal with its coefficients, its properties. So majorly the most or the highest number of questions are asked from these two topics. If I were to define the second most important chunk, then it is going to be the remainder theorem, divisibility problems, unit digit, last digit, and questions based on summation of series. These are the four topics where you should put your complete focus upon. I am not denying that this is having somewhere least or the lesser importance. This has its own questions. Questions are asked from this particular topic as well. But yes, the most prominent ones are going to be these two and these two. I hope you're getting complete clarity on it. So rather than discussing what is important and what is less important, where we know that everything is equally important, let us discuss first of all, how do you understand binomial theorem or binomial expansion? And to get more clarity on it, you should have clarity on Pascal's triangle or Pascal's theorem. So if you know how did they actually develop the logic, so if you start looking at the patterns of the expansions of binomial terms, for example, if I were or if I could begin with x plus a to the power 0, I would have noticed that x plus a to the power 0 will result into 1. Let me write these expansions first, then we'll start noticing the patterns, and then you can generalize the binomial expansion by yourself as well. Yes. Now, if I talk about x plus a to the power 1, I hope you know that x plus a to the power 1 will be expanded as x plus a. What if I were to ask you that expand x plus a square? You will say that it is x square plus 2xa plus a square. What would be your response if I were to ask you expand x plus a cube? You would have said, sir, it will be x cube, then 3x square a, then 3xa square plus a cube. Are you getting a complete clarity on this part? How did I do this? Now, if this is what you know, I am asking you to look at the pattern to recognize something more important. When I began with x plus a to the power 0, what was the coefficient? I had only one term and that term had the coefficient as 1. Okay, that's great. Now, when we expanded x plus a to the power 1, the terms were x to the power 1 and a to the power 1. Alright, we'll talk about these powers later, but let us first of all discuss the coefficients. What were the coefficients? The coefficient of x was 1, the coefficient of a was also 1. So basically, initially I got 1 as the coefficient in x plus a to the power 0, and then I got the coefficients as 1 and 1. Now, let us look at x plus a to the power 2. So in x plus a to the power 2, I got coefficient as 1, 2 and 1. The coefficients were 1, 2 and 1. Look at the pattern now. So I got the coefficients as 1. I hope you can see 1 plus 1, 2 and then 1. Are you noticing something? Let us expand it further. Let us get into more details of it. When I expanded x plus a to the power 3, I got the expansion as the coefficients as 1, 3, 3, 1. What does it mean? It means 1, 1 plus 2, 3, 2 plus 1, 3, and then you have this 1. Are you getting the logic? Now, even if I don't tell you what will be the coefficients of x plus a to the power 4, then you may be able to generate with the help of x plus a cube. Because in x plus a cube, the coefficients were 1, 3, 3, 1. So if I look at the pattern, in x to the power 4, I would be having the coefficients as 1, 1 plus 3, 4, 3 plus 3, 6, 3 plus 1, 4, and 1 will remain 1. The extremes will remain as it is. Now, which term will appear where? That's another question. So that is even more easier. How? Please look at the pattern here. What did I start with? I started with x to the power 1, a to the power 1 in the expansion of x plus a to the power 1. When I begin with x plus a to the power 2, I wrote x square a to the power 0. Then I wrote x to the power 1 a to the power 1. And then I wrote a square x to the power 0. So I am trying to make you understand that every term will have the sum of the powers as the sum which is written over here, the power which is written over here. When I'm expanding x plus a whole cube, the power is 3. So here in the expansion, each term will have the sum of the powers as 3. If you are noticing, see, x cube a to the power 0, sum is 3. X square a to the power 1, sum is 3. x1 a square, sum is 3. X to the power 0 and a cube, the sum is still 3. Are you noticing the pattern? And one more pattern you must notice. The way the powers of x are diminishing, simultaneously the powers of a are increasing. So initially if the power of x was 3, in the next term power of x was 2, in the next term power of x was 1, and the final term the power of x was 0. Similarly, simultaneously, if the power of a was 0 initially, in the second term power of a became 1, in the next term power of a became 2, and in the final term power of a was 3. Are you able to get this part? Now, if you have understood this pattern, can you predict what will be x to the x plus a whole raised to the power 4? Now, if I were to ask you x plus a whole raised to the power 4, first of all, you would say, sir, let us talk about coefficient later. First of all, let us find the terms. Then we'll write the coefficients as well. So you would say, sir, it will begin with x to the power 4. Yes, x to the power 4, a to the power 0. Then you would write x cube, a to the power 1. Then you would write x square, a to the power 2. Then you would write x, a cube. And then finally you will write a to the power 4. I hope there is no confusion on it and you are able to see this part here, a to the power 4 very clearly. I hope it is properly visible to everyone. If it is not, let me write it here with this a to the power 4. I hope it is properly visible now. Now, the next part. What about the coefficients? I think we have already had the coefficients 1, 4, 6, 4, 1. Write them. So, the coefficients will be 1, 4, 6, 4 and 1. So, this is exactly nothing but the expansion of x plus a to the power 4. So instead of x plus a to the power 4, you are not expanding it in the manner the way you are supposed to, in which you multiply x plus a 4 times with itself. No, we have understood a certain pattern and now we are able to predict the expansion. Even if I were to ask you x plus a to the power 5, with the help of Pascal's triangle, you would say x to the power 5 into 1. Then x to the power 4 into a to the power 1 into 5, because second term will have the coefficient 5. Why? I hope you're realizing it. 4 plus 6 is 10. So the next term will have the coefficient 10. Then another term 6 plus 4, the coefficient will be 10. Then 4 plus 1, the next term, the second last term will have the coefficient 5, and the final term, the last term, will have the coefficient 1. So I hope you can predict the terms and their coefficients based on it. But the problem with the Pascal's triangle is, let's say if I were to ask you x plus a to the power 20, do you not think that you will have to create this entire triangle? Then that will become more cumbersome. And that's where you need to understand that if we are able to generalize this, we should be able to generalize it in a more general manner with the help of binomial theorem. So if you have understood this, that how did Pascal help us in understanding the pattern and looking at the sequence, you can actually get the more clarity through binomial theorem on these expansions. So bi means two, nomial means an expression. So whenever you are expanding an expression containing two terms, which is having a certain power, then such expansion can be understood with the help of binomial theorem. What does it mean? Let's say you're having two terms, x plus a, and it is having a power 4. So its expansion is written in this manner. Now, what does the binomial theorem say? Of course, with the help of Pascal's triangle, you could have written it like this. But do we have any other method through which also this can be done? Yes. And that is exactly what is called the binomial expansion or the binomial theorem. Now, what does it say? It says that if you were to begin with x plus a to the power n. Now, I hope you're realizing n means could be anything. N means any natural number so far. So let's say we are dealing with x plus a to the power 4. Now you wish to write, or now you need to write x plus a to the power 4. Now how do you do it? The idea is very simple here, students. What you do is, you first of all write 4C0. Now what is 4C0? You know it. You study it in permutation and combination. Even if you don't, we will discuss these coefficients. We'll discuss their properties as well. We'll discuss questions based on those properties as well. So don't worry about that. But first of all, let's say you are expanding x plus a to the power 4. You write it as 4C0. And then of course, you begin with the highest power of x, which is x to the power 4 and a to the power 0. Then you write the next term. What is the next term? In the next term, you write 4C1. X power is decreased or diminished by 1. So there I'll have x cube, which is x to the power 4 minus 1. And the power of a is increased by 1. So I'll have power of a as 1. Then in the next term, I'll write 4C2, x to the power 4 minus 2, a square. So the coefficients which we were able to deduce with the help of Pascal's triangle are now being generalized as NC0, NC1, NC2, NC3 and up till NCN. So first of all, I hope you are able to digest this part, that this is nothing but even a more generalized version of Pascal's triangle only, where I hope you can see this thing very clearly. You initially, in the first term, you begin with the highest power of x and the lowest power of a, and then gradually with the upcoming or the further terms, you keep decreasing the powers of x and increasing the power of a by 1. But what about the coefficients? So coefficients are also a very simple part. You straight away initially begin with NC0, then you take it to NC1, then NC2, then NC3 up till NCN. So that's how you take it to the last term. Any confusions on that front, students? I hope you're able to digest the binomial theorem and its expansion. If by this method, if through this expansion, if I could, or if I were to write the expansion of, let's say, x plus a to the power 4, how will I write it? I repeat, the formula remains very simple. I'll begin with 4C0. This is how I remember personally. Then I write x to the power, the difference of these two, which is 4 minus 0, and a to the power, this term, this expression, which is 0, plus the next term will be 4C1, the difference of these two, so 4 minus 1 is 3, and a to the power, this expression, which is 1, plus the next term will be 4C2, then x to the power, the difference of these two, which is 2, and a to the power, this term, which is this. Then you'll write the third term, next term, and then the final term. The final term will be 4C4, x to the power 4 minus 4 is 0. So I hope you are understanding this is the final term, into a to the power this number, which is 4. The only term which I did not write, let me write that also so that you don't get confused at all. So the next term would have been, the second last term would have been 4C3, x to the power 4 minus 3, 1, a to the power 3. So these are the 5 terms in the expansion of x plus a to the power 4. How do you write 4C0, 4C1, 4C2, 4C3, 4C4? Don't worry about that. We'll learn that expansion as well. But this is how you write the expansion of a binomial expression through binomial theorem. Did you get that part? Any confusions on that? So if I were to generalize this formula, I'll ask you to remember this particular result, where x plus a to the power n is written as summation of NCR x to the power n minus r a to the power r, where r begins with 0 and reaches till n. So plus summation sign is you keep putting between these expressions, and that's how you write its expansion. So this is something, if you could understand, if you could notice, if you could interpret or comprehend, then it will be very easy for you to write binomial expansion of any expression. Getting this part, everyone? Now, moving ahead. As we have already discussed, NC0, NC1 are called the binomial coefficients, right? Here, let's say what I do is, if I replace n by n minus r, trust me, no changes are done here in this case. Also, if I am replacing n by n minus r, basically what you all must understand is, I hope you will all agree, you all must agree that whenever I write x plus a to the power n, or whether I write a plus x to the power n, will you not say, will you not agree with this fact that it will be same? Because either x plus a to the power n you write, or a plus x to the power n you write, both of them are going to be same. Why should they be same? Because if I could take you to the binomial expansion again through Pascal's triangle, look at the coefficients. If the first term has the coefficient as 1, if the first term has the coefficient as 1, the last term also has the coefficient 1. So first and last term have the same coefficient. Look at the second term and the second last term. They have the same coefficient. Look at the third term and the third last term. They have the same coefficients. Even if the number of terms were odd, for example, in the expansion of x plus a to the power 4, look at the first term and the last term, second term and the second last term, third term and the third last term, which is same. So here also the coefficients were same. Are you getting this part here? So that's why I am trying to make you understand this part here, that even if you replace x plus a by a plus x, the expansion will look exactly same. So coefficients won't change. If you look at the first term and the last term's coefficient, if you look at the second and the second last term's coefficient, if you look at the third and third last term's coefficient, not just that, what you should remember is that there is a property which we study in PNC, that NCR is equal to NC n minus r. So through that also, you will remember this particular result, that whether you write the expansion of x plus a to the power n or a plus x to the power n, it will be mathematically same. I hope you're realizing why and how. Now, if that part is understood by you all, this is exactly what they are trying to say or convey here. Now, some more conclusions, some more corollaries can be drawn based on what we know as far as binomial coefficient or binomial expansion is considered. So far what we have discussed is the expansion of x plus a to the power n. What if I replace a by minus a? So instead of a, now let's say I'm dealing with minus a. So instead of a, if I'm having minus a, do you not think that here, if I'm having minus a, all the a will get replaced by minus a? So whichever term has the power of a as odd, it will have a negative sign before it. And if the term has the power of a as even number, then the power even will make that negative number as positive. So what you need to understand is that x minus a to the power n will have the same expansion as x plus a to the power n, except for the change where whenever you are dealing with the power of a which is odd, then there you need to take the negative sign. I hope you're understanding why. So x minus a to the power n will have the first term as nc0 x to the power n a to the power 0. But in the next term, when you're dealing with a to the power 1, which is odd, I'll have minus nc1 x to the power n minus 1 a to the power 1. Again, in the next term, when a square is there, I'll use plus nc2 x to the power n minus 2 a to the power 2, and so on. So if I were to generalize this expression, I will say that x minus a to the power n is given by summation of minus 1 to the power r. What is r here? A to the power r. So it is going to be NCR x to the power n minus r a to the power r, but you'll have minus 1 to the power r, because whenever r is odd, it will give me a negative expression. Whenever r is r is even, it will give me a positive expression. Did you understand that part? So I hope x minus a to the power n, this expansion is also very well understood by you all. Now the next result is more important when you are asked to write the sum of these two. This is what we might be using at a lot of places. X plus a to the power n plus x minus a to the power n. Now, are you realizing all the terms in x plus a to the power n where a had an odd power will get cancelled by the terms in x minus a to the power n? Because those odd powered terms of a will be positive and negative here and here, and the rest of the terms where the power of a was even will get doubled. What I'm trying to make you understand is a very simple phenomena that whenever power of a is even, that will be added. But wherever you see the power of a to be odd, so in this expansion it will be positive and in this expansion it will be negative. So positive and negative, they'll get cancelled because magnitude wise they'll be same. So yes, the terms with the powers of a as even is what you will be left with. And of course, these terms will get doubled because they'll be present in the expansion of this and this both, which means the expansion of this is written as double of nc0 x to the power n a to the power 0 plus nc2 x to the power n minus 2a square and so on. Did you get this part? Any confusions on that? Similarly, now, instead of adding, if I were to subtract it, I'll show it with an example. Let's say here, I am having, x plus a cube minus x minus a whole cube. Now, what will you have? Most of you must be able to comprehend it by seeing it at only. But if you were getting confused, let me give you clarity. X plus a whole cube will be x cube plus 3x square a plus 3xa square plus a cube. But when from this expression, when you subtract x minus a cube, it will be x cube minus 3x square a plus 3xa square minus a cube. I hope you can see when I was writing the expansion of x minus a whole cube, this turned out as negative whenever the power of a was odd. But here, instead of adding both of these expressions, I'm subtracting them. So whenever you're subtracting them, do you not realize that this time, the expressions or the terms with odd power of a will get doubled? Because please understand, x cube will cancel x cube. But this term and this term will get added. I hope you are understanding why. So this time I'll get double of terms with even powers of a, if I could generalize it in a single statement. Because now I'll get double of 3x square a. I'm really sorry. I think I have mistakenly written the wrong part. When it was the plus sign, then I was supposed to write the even powers. This time it will be the odd powers. I'm really sorry for this. So here, 3x square a will get doubled. Then a cube will get doubled. So two terms will appear here because this x cube will get cancelled by this x cube. This 3xa square will get cancelled by this 3x square. But the remaining terms which are having odd powers of a will get doubled. Why? Because this time I'm subtracting it. So minus minus will become plus. Did you get this part? Now, moving ahead. If I, instead of writing the expansion of x plus a to the power n, if I were to write the expansion of 1 plus x to the power n. Now, please understand, this is how simple it is. Now, if I were to make you understand what is it, I'll begin or I'll write it with an example again. Let's say I am writing the expansion of 1 plus x whole raised to the power 5. Now, how do you write it? Trust me, the expansion is so simple because no matter whatever power you raise 1 to, it will always give you 1. So I need not bother about 1. So I'll begin with 5c0. The first term will have the coefficient as 5c0. 1 to the power 5, which doesn't matter, into x to the power 0. Then the next term will be 5c1. 1 to the power 4. So 1 will have certain powers which I don't need to write because 1 is 1. So I'll be writing here x to the power 1. Then the next term will be 5c2 x to the power 2 and so on up till the last term, which is 5c5 x to the power 5. Did you understand this expansion? So I am again asking you to remember this also as a result. Whenever you're asked to write 1 plus x to the power n, then its expansion is given by summation of ncr x to the power r, where r is ranging from 1 to n. Did you understand this part as well? Now, moving ahead, let us get more clarity on 1 minus x to the power n. Again, did you realize and understand that again the power of x will decide the term's sign, whether it will be plus or minus. So again, if x is having a power odd, the term will have a negative sign, and if the power of x is even, the term will have a positive sign. Did you understand my part here? If you didn't, I'll explain it with an example, of course. Let's say I need to write 1 minus x to the power 6. So I hope now you understand the expansion. I'll begin with 6c0. Of course, here I'll be writing minus x to the power 0, which is basically 1 only. So I could write it as x to the power 0 only, or I could keep it 6c0 only. But in the next term, I'll be having minus x to the power 1. So here I'm putting this minus here and I'm writing it as 6c1x. Did you get it now? Now I hope it's easy for you. Then in the next term, you'll write it as 6c2 minus x square, which will be x square only. In the next term, it will be 6c3 minus x cube, which will give you a negative sign over here. And so on until the last term is attained, which is going to be 6c6, and minus x to the power 6 will make it positive. So all of this depends on what power of x you are dealing with. If the power of x is even, you will have a plus sign. If the power of x is odd, you will have a negative sign. And I hope you're realizing why. Now, if this part is understood, again, I hope there is no confusion on this front. You have understood it very clearly. There are some things, or there are few things which you need to understand as far as properties of binomial expansions are to be understood. Why? Because this is something which is not just used here in this binomial chapter only, but you will use these properties in permutation and combination or at some other places as well, depending on the requirement of the question. So pay a lot of attention on this front, because questions are asked from based on the properties of binomial coefficients, and they are used throughout your mathematics anywhere in any chapter. So remember them, learn them, and whenever you see or observe such opportunity of properties of binomial coefficients getting applied, do avail that. How? Let's look at that. See, first of all, the very basic observation which all of you must have made is that here, if the power was 6, the number of terms were 7. So when I expanded it, I began with 6c0 and I ended with 6c6. So the number of terms in this expansion were 7. I hope even in the initial part also, when you must have noticed here in the Pascal's triangle as well, here also, why is it not going up? So let me just take you there with the Pascal's triangle. Where is it? Here it is. So even in the Pascal's triangle also, see, when the power was 0, there was 1 term. When the power was 1, there were 2 terms. When the power was 2, there were 3 terms. So if the x plus a, the binomial expression, has power n, it will have n plus 1 terms. Please remember that. Now, let me get back to the conclusion we were having here. The second property is, as we have just previously discussed, NCR is equal to NC n minus R. As we have had a discussion on it, the coefficient of first and the last term, the coefficient of second and the second last term, the coefficient of third and the third last term. This is exactly what they are writing over here. So don't get confused with that part. Second thing, before we go ahead or move ahead with this part, I hope I did not give you this clarity that how do you write the expansion of NCR. So there is a standard formula for it, which is given by n factorial upon r factorial times n minus r factorial, right? There is a short technique as well. For example, let's say if I were to expand 5c2, so the standard method says that 5c2 can be written as per the formula 5 factorial upon 2 factorial into 5 minus 2 factorial, which is going to be 3 factorial. That's a standard method. But if you don't want to use this standard method, there is a shortcut as well. Through shortcut, what you do is, let's say I need to find the value of 5c2. So 5 in a reverse manner, I'll expand up till 2 terms. So 5 into 4. These are the 2 terms. I hope you're realizing it. Then in the denominator, I'll write 2 in a reverse manner until 1. So I'll write 2 into 1. Even when this is expanded, you'll get the same result. So whether you apply this formula or you use this short technique, they'll give you the same result. Now, moving ahead, let us discuss this thing. In any term, the suffix of c is equal to the index of a, as we have already seen, observed and discussed. And the index of x is always n minus suffix of c. I'll re-repeat this part, that if I'm writing x plus a to the power n, its expansion, then its expansion is given by summation NCR. I hope you remember. So the power of x is always the power of x is always n minus r, and the power of a is always r, where r begins with 0 and goes till n. This is how you generalize the binomial expansion, and this generalization is exactly concluded here with this part. Now, in each term, the sum of indices of x and a is equal to n, as we have already discussed, that the sum n minus r plus r is always n minus r plus r, which is n. So the sum of the powers of x and a is always going to be n. That is what they are trying to say. So these are some observations or conclusions which we have already drawn. Now, let us look at this property. Usually, we write NCR as NCR, but in some questions, by JEE means you may end up seeing either Cn comma r or bracket nr. So here above n and below r will be written like this. So even if you see something like this written in the question, don't get confused. Don't treat it as p, it is always c. So NCR sometimes is written as this expression as well. Do take care of this. Students usually get confused and they end up getting stressed in the real examination hall. So even this C n comma r or this bracket nr is written over there, it should be treated as NCR. Will you remember that? Moving ahead, what do we see next? Yes, this is again a very important conclusion. The moment students see NCX is equal to NCY, they end up concluding or saying that X should be Y. But as we have already seen the property that NCR is equal to NCN minus R. And that's how you should understand that. For example, if I were to try to make you understand, let's say if you have 5C3 and 5C2 written equal, then I hope you're realizing this is equal, because 5C3 is equal to 5C 5 minus 3, which is 2. So I won't say that 3 and 2 are equal. But what I would say is that if NCX and NCY are given equal, then yes, there is a possibility that this and this could be equal. Or the second possibility, which I'm trying to demonstrate here, is that n could be equal to x plus y. What does it mean? 3 plus 2 could be 5. So I hope you will remember this also as a result, and this is the proof through which it can be understood. This is what we all know, that NCR is equal to NC n minus R. Do take care of this thing. Now, moving ahead, the most important formula on which JEE loves asking questions is this. NCR minus 1, sorry, NCR plus NCR minus 1 is always n plus 1 CR. What does it mean? I'll try and give you an example so that you keep this with you. For example, let's say I am given 5C4 plus let's say 5C5. I am given 5C4 and 5C5. This is what you will notice at a lot of places in the questions, not just in the questions of binomial expansion, but this coefficient has its own this property and it is used in other chapters as well. So there can be a question on integration and there you might be seeing something like this, and then you are asked or supposed to apply this particular property. What does it say? First of all, the observation should be this, that you should be able to notice that this n then this n should be same. And this r minus 1 should be consecutive. This is what you should notice. So how I personally remember it is as that I increase this n by 1. So if this is 5C4 and 5C5, the n was fixed, which is 5, which is same in both the cases. So I'll increase it by 1, which is I make it 6. Did you get this part? I'll write it as 6. Then after increasing it by 1, out of this 4 and 5, whichever is greater, of course 5, I'll write that. I repeat. So here, this is the interpretation of it. Now, most of you must be saying, sir, this is so simple. Why is it so important? Trust me, this is not just a very simple or an ordinary property. This has its own implication. A chain gets created when something of this sort is given to you, and questions are done within 10 seconds if you are aware of this property. So I repeat, please remember this. This is a very crucial result, and do take care of it. Sometimes this is also written as, let me write it here. Sometimes this is also given as, let's say, NCR plus NCR plus 1. So don't get confused with this thing. All you need to notice is that this n and this n should be same, and these r and r plus 1 should be consecutive, which they are. So what you do is, as you are already told, repeat n but with increment of 1. And among those r and r plus 1 or r minus 1 and r, whichever is higher, write that. So I hope you are getting it very clearly. So n, I'll increase n by 1, so it will become n plus 1. And here between r and r plus 1, the greater one is r plus 1, so I'll write r plus 1. Did you understand this part as well? This is that same property but written in a different manner. I am very, very strongly asking you to remember this, to take a note of it, because questions are going to be asked from this particular property. Did you get that part? Now, let us move ahead. Let us take some more clarity. What do you understand by NCR and NC R minus 1 and its ratio? So, of course, here if I were to expand it, what I'll say is NCR divided by NC R minus 1 is what I need to work upon. So what do you understand by NCR? We have learnt the formula. NCR is given by n factorial upon r factorial into n minus r factorial. Are you getting it? Whole divided by. What about NCR minus 1? Sir, NCR minus 1 will be given by n factorial upon r minus 1 factorial into n minus r minus 1 factorial. I hope you're getting it very clearly. So it will be n minus r minus 1 factorial. Now, what are you understanding through this? Most of you must have noticed that, sir, here this n factorial and this n factorial are cancelled. Now, can I write this r factorial as r into r minus 1 factorial? Because I hope you know that 5 factorial can be written as 5 into 5 minus 1 factorial. So if I could use this property over here, this r factorial, I can replace r factorial by r into r minus 1 factorial. Now when I do so, this r minus 1 and this r minus 1 factorial is cancelled. I hope there is no confusion on it. Even if you look at this particular part, which may look a little confusing to you, so I'll simplify this first, then we'll talk about this later. So when I simplify this first, so that you don't get confused anymore, this will come in the numerator. So what will it be? It will be n minus r plus 1 factorial in the numerator, and in the denominator I'll have this r, I hope this is all what I'm left with, into n minus r factorial. I hope there is no confusion on it. Now, can I not write n minus r plus 1 factorial as n minus r plus 1 into n minus r plus 1 minus 1 factorial? I hope you're getting it. 5 factorial, 5 into 4 factorial. That's exactly what I've done. So n minus r factorial gets cancelled by n minus r factorial, and you're left with n minus r plus 1 upon r. Sir, why should we learn it? Of course, you are free to derive it anytime, however many times you want to, but I hope you're realizing it has consumed at least 10 to 15 seconds if even you're doing it your fastest speed. What I'm trying to make you understand is that this is something which is used a lot many times in a lot of questions. So even if you're dealing with questions on binomial coefficients or pre-NC or even some other chapters, this is what you may encounter. Even in sequence and series also they say that these terms are in AP or something like that. So please remember that this is what you may have to deal with. So when you deal with something like this a lot many times, why should you derive it every time? Why should you not learn this as a result and apply it as many times as you're required to use it? Even if you're bad at remembering things, don't hesitate. Practice a lot of questions so that you remember it, so that you learn it, so that you by heart it. So do a lot of practice. That's another key component which you should do. So there are two things. Either you derive it every time, which will consume a lot of time every time, and that is what you don't have. So yes, if at this stage, before getting into the examination hall, if you can invest some time and learn this formula, then why should you not learn it? Are you understanding the strategy? So yes, please remember it. If at this stage you have the time to memorize it, invest some time in understanding and learning it through practice, of course. So if this part is very well understood by you all, the next property is even simpler. Always remember, I'll explain it with an example here. Let's say I have 10C, let's say 4. So always remember 10C4 can be written as 10 by 4 into, what is 10 minus 1? 10 minus 1 is 9. What is 4 minus 1? That is 3. So I can write it as 9C3. I hope you are understanding. The only important property, another very crucial property which I'm trying to make you understand, is that NCR if needed, which we will need at a lot of places. That's exactly why am I making you understand this, that NCR is written as n upon r times n minus 1 CR minus 1. And through example, you must be able to understand NCR is n upon r, n minus 1 CR minus 1. Do remember these two results. They play a very crucial role in your JEE journey. Please take a note of it. They are going to be some really important and crucial formulae. Now, as we have already discussed the expansion of a binomial expression, how do you write its general term? So if I could simply try and give you the idea, will you not agree that, sir, if I talk about the first term had NC0, the first term was basically NC0, x to the power n minus 0, a to the power 0. The second term was NC1, x to the power n minus 1, a to the power 1. The third term was NC2, x to the power n minus 2, a to the power 2. So I hope you're realizing, if I'm talking about r plus 1th term, I'm not saying rth term, I'm deliberately, intentionally saying r plus 1th term. So if I'm willing to write the r plus 1th term, will you not say it will be NCR, x to the power n minus r, a to the power r? Are you understanding this intent? So for example, again, if I were to explain you this part, let's say in an expansion, let's say I am writing the 5 plus 1th term, which is what I am asked to write the 6th term. So 6th term, first of all, mentally I'll take as 5 plus 1th term. I hope you are understanding why. And let's say I am writing this term as an expansion of x plus a to the power, let's say 10. So what is n here? We all know n is 10. So I'll be writing it as 10c. I hope you are understanding. Nobody should take c, then r as 6. That will be wrong. R should be taken 5 in case of t6. Getting it, everyone? So it should be 10c5. Then of course, this x to the power, difference of these two, 10 minus 5 is 5, and a to the power this number, which is 5. Any confusions on that? This is not the 5th term, students. This is the 6th term. Take care of it. I hope you are getting complete clarity that r plus 1th term is NCR, x to the power n minus r, a to the power r. Are you getting it very clearly? Any confusions on that? Now, let us move ahead. Let us see a question and now understand whatever we have discussed so far, whether you are able to consolidate all those learnings into this one question or not. So if you have understood whatever is explained so far, pause this video right here and attempt it by yourself. Although I am starting to solve this question, and let's first of all understand what are we given here in this particular question, right? So let me begin with this part. Just give me a second, students. Here, let's say if I'm beginning with this, so what are we asked? The term independent of x. Okay, we'll talk about that later, but I need to write the expansion of this. Okay, so this looks terribly confusing, and that's what they do. So students, by looking at this question only, may think that this is not your cup of tea, this is not my cup of tea, I should skip it and I should move to the next question. And that's exactly what we are trying to make you understand, that this is that category of question which is doable, which is somewhere between easy and moderate. To me, of course, it is a very easy question, but even if you are doing it or attempting it for the first time, it will not classify as a tough or a hard question. You can, up to an extent, call it a moderate level of question. So there are certain questions which may look tough or not doable or not doing worthy, but still they are easy if you are able to crack the pattern. Now, how will you look at the pattern, sir? How confusing this is? Are you not seeing or noticing that finding the term which is independent of x in the expansion of this expression, this expression, how difficult is it going to be? I'll still say, please pay attention to the expressions. And if you remember the identities which we have learned in the chapter quadratic equations, you will say, yes, this is very easy. And that's exactly when we say that every chapter, every concept is equally important. So stop asking questions that which one is more important, which one is less important. Everything is equally important. JEE means and advanced own this responsibility to ensure that they ask you everything directly, indirectly, subtly. This is their responsibility. Don't worry about it. So they will ensure that they ask everything. So when you say that this was there in the examination, this was not there in the examination, trust me, everything will be asked in the examination hall. So any student who prepares for everything, who studies everything, will attain a good score. Don't have this assumption that only important topics are to be done and through that you can score well. No, that's not what they do. Trust me, they have this technique that they will ask you everything. Because here this question may look like a question on binomial, but it uses the concepts of inequality identities. How? Let's have a look at that. Let me deal with this first part here. What is it, sir? It is x plus 1 in the numerator divided by x to the power 2 by 3 plus 1 minus x to the power 1 by 3. Now, if I get back to you, or if I take you to the first session which we have studied in the quadratic equations, we had a discussion on these expressions. Let me first of all take you towards an identity. Do you remember something as a cube plus b cube? We have learned how to write a cube plus b cube. We have learned that a cube plus b cube should be written as a plus b, a square minus ab plus b square. This is what we have learned, right? Do you remember recalling, or are you able to recall it? Now, if this is what you have learned, let us look at this part. What do we have in the numerator? X plus 1, right? So x plus 1 divided by x to the power 2 by 3. So there you have x to the power 2 by 3 plus 1 minus, I think, x to the power 1 by 3. Great. How do I deal with this expression? Let's have more clarity on this. Please understand, the numerator which is x plus 1, the numerator which is given as x plus 1, I am rewriting it as x to the power 1 by 3 whole cube plus 1 to the power 1 by 3 whole cube. Or even if I write 1 as 1 to the power 3 also, that is also fine. So can I do this first of all? I hope you can see it, that this 3 and this 3 are nullified. You are still left with x plus 1 in the numerator. So that expression remains intact. No changes are made so far. But in the numerator or to the numerator, if I apply this identity a cube plus b cube, what would it look like? It will look like a plus b. What is a plus b? A plus b is going to be a plus b times a square. What will be a square? A square will be x to the power 2 by 3 minus ab. What will be minus ab? It will be x to the power 1 by 3 into 1 plus b square. What will be b square? It will be 1 whole divided by this expression, which I need not explain, is exactly the replica of the factor given in the numerator. Are you not able to notice this result here, students? Do you not, or will you not agree with this result here, students? Just give me a second. I'll just okay, skip this as of now. So I am trying to tell you that this and this factors are identical. Are they not? And on the basis of this, you will be able to conclude that the first term was simply x to the power 1 by 3 plus 1. I repeat. So this is x to the power 1 by 3 plus 1 only. Which part? This part. So this part, which looks very much confusing, is not. It clearly is not. Are you getting this? Now, once you have cracked it, will you not be able to crack this part as well? Let us now look at this. X minus 1. I hope this is what we have received as. The first part we have received as x to the power 1 by 3 plus 1. So I'll write it here. X to the power 1 by 3 plus 1. Now let's talk about the next part. The next part has the numerator as x minus 1. And the denominator of the next part is x minus x to the power 1 by 2. Okay, x minus x to the power 1 by 2. Okay, let's work on simplifying this. Before I start working on simplifying this, from the denominator, I'm taking x to the power 1 by 2 common. Okay, so when I do so, I am taking x to the power 1 by 2 common. So once you have taken x to the power 1 by 2 common, here you are left with x to the power 1 by 2 and here you are left with 1. I hope this part is understandable. So under root x is taken common, then you are left with root x minus 1. Did you get that? Now let us look at this part, x to the power 1 by 2 minus 1. If I look at x minus 1, if I could use the identity a square minus b square, can I write it as x to the power 1 by 2 whole square minus 1? Now, if this one I wish to write as 1 square, that wouldn't make any difference in this particular expression. But now if you look at this particular part, it looks like a square minus b square. What is a square minus b square? It is a plus b into a minus b. So a plus b into a minus b will help you in writing the numerator as a plus b, which is going to be x plus 1 by 2 plus 1, into a minus b, which is going to be x to the power 1 by 2 minus 1. I hope there is no confusion on it. A plus b, a minus b. What about the denominator? The denominator has x to the power 1 by 2 into other factor is x to the power 1 by 2 minus 1, which is exactly what you are now dealing with in the numerator and denominator both. So now if I were to finally simplify this and write this, do you not agree that this is x to the power 1 by 2 plus 1 upon x to the power 1 by 2? So if I individually divide both of these terms by x to the power 1 by 2, so this upon this will be 1 plus 1 upon this will be x to the power minus 1 by 2. So the next term which we had is nothing but this entire expression is 1 plus x to the power minus 1 by 2. Now, this is needed to be subtracted. So it should be minus 1 minus x to the power minus 1 by 2. So this is your expression, which is raised to the power 10. And we are told that x is greater than 1. Great. X is greater than 1. Brilliant. Now, even if you pay more attention to this part here, I can very clearly see that 1 is getting cancelled by 1. So now we are left with the expansion of x to the power 1 by 3 minus x to the power minus 1 by 2 whole raised to the power 10. Right. This is what we are dealing with now. Now, I am asking you to write its general term. I hope you remember that if I am asked to write the general term of, let's say, a plus b to the power n. Do you remember how to write the general term? I hope I need not make you recall that r plus 1th term is given by ncr a to the power n minus r and b to the power r. Do you remember this result? So again, if I were to use this same result over here, let's say instead of dealing with this expression x to the power 1 by 3 and x to the power minus 1 by 2, which I'll do later, see, let's say this is x to the power 1 by 3 minus x to the power minus 1 by 2 whole raised to the power 10. I hope this is exactly what we are doing. So here, if I wish to write it, then will I not write this expression as its general term? It's r plus 1th term, right? I'll be writing it as ncr, which is going to be 10cr times this first term, which is x to the power 1 by 3 whole raised to the power 10 minus r into this minus x. So minus x, right? So can I get rid of this minus x here? So minus x is going to give me minus 1. So that minus 1 to the power r I'm writing here. And then again I'm writing this 10cr. And then I'm writing this x to the power minus 1 by 2 whole raised to the power r. Are you comfortably understanding this? So this rth term in a more simplified format will now look like minus 1 to the power r, I hope you are comfortably understanding it, times 10cr. What about this x? So this x will be raised to the power to 10 minus r by 3. And what about the other x? This x will be raised to the power minus r by 2. I hope there is no confusion on it. And when the bases are same, powers are added when product happens. So here, if I further wish to write this r plus 1th term, it will be minus 1 to the power r 10cr. You need not write this part time and again, just work on this. Why? I'll tell you now. So here, x will have the power as 10 minus r by 3 minus r by 2. So this is going to be 10 minus r by 3 minus r by 2. So this is going to be 2 into 10, which is going to be 20 minus 2r minus 3r, which is going to be minus 5r upon 6. Did you get this part? So this is going to be the power of x, which is going to be 20 minus 2r minus 3r upon 6, which is going to be minus 5r upon 6. So this is the power of x. Now, let us get back to the question. They were asking you to find a term which is independent of x. Now, what does it mean? I am looking to find a term which is independent of x. Now, if there is a term which I need to find which is independent of x, then will you not agree that if a term is independent of x, then there should not be there should be a no term in x, which means the power of x should be 0. So here, if the power of x is 20 minus 5r upon 6, then this power over here, which is 20 minus 5r upon 6 should be 0. Because if this becomes 0, if this power becomes 0, x to the power 0 will give you a term which won't have any x. So that term will be independent of x. Are you understanding the approach? So 20 minus 5r upon 6 is going to be, 6 goes there, 20 minus 5r is 0, 5r is 20. So if 5r is 20, you get the value of r as 4. You get the value of r as 4. I hope there is no confusion on it. Now if I put the value of r as 4, I'll get the term which is independent of x, right? So if I find this term, If I'm asked which term is independent of x, I'll say when R is 4. So when R is 4, it is the fifth term. So fifth term is going to be independent of x. Well, that's not the question. I'm asked to write that term which is independent of x. So I need to write the fifth term. So fifth term is going to be t 4 plus 1, as we already know, is going to be, as we have this expression here, minus 1 to the power 4 minus 1 to the power 4, which is very easily understood by all of us, is going to be 1 only, and then 10c4, and then 10c4. So minus 1 to the power 4 is going to be 1 only, and then you need to find 10c4. 10c4 when expanded with the help of this shortcut is going to be 10, 9, 8, 7, 4 terms in reverse order divided by 4, 3, 2. So again, I hope this part is doable, because here 4 into 2 4 into 2 is 8, and 3, 3, 9. So 7 into 3 is 21, into 10 is 210, which you are given in option A. I hope easy it was, comfortably doable. Not much was needed to be done if you know the basics, if you know the nuances. Everything we discussed in this particular question was doable. Two things you should have been aware of: identities. Of course, after identities, the next crucial part would be that nth term, or the r plus 1th term in the generalization of a binomial expansion. I hope simple question it was. Let us solve one more question so that we can understand how do you deal with binomial coefficients, because these are the two important topics from where questions are asked. The most or the highest number of questions are asked. Let us look at this question asked by JEE Mains in 2024. What does it say? So it says you need to find the coefficient of x to the power 70. Okay, so I'm asked to deal with the coefficient of x to the power 70. Can you help me with this term, then this term, then this term, then this term, then so on up till last term? Okay, I think there will be a pattern, and that pattern needs to be generalized. And that pattern, when finally simplified, looks like this, there and where I need to find the value of q. Okay, I'll begin with the first part. I'll break my problem into first part, and then I will talk about this part only. X square into 1 plus x to the power 98. If I'm asking you to find the coefficient of x to the power 70 in x square into x to the power 70 in x square into 1 plus x whole raised to the power, I think, 98, then what will be your response? You may say that, sir, here in this case, what you need to understand is very clearly that this front has x square will be there. So all the terms which I'll expand after 1 plus x in x 1 plus x to the power 98, there'll be certain powers. I'll begin with the power of x as 98, 97, 96 up till x to the power 0. So all these terms will be there. But I need the term which is having x to the power 70. So do you not agree that if I am able to find the coefficient of the term which is having x to the power 68, then if this is multiplied with this, then I'll get a term in x to the power 70. Are you getting my logic here very clearly? So if I'm asked to find the coefficient of x to the power 70 in x square into 1 plus x to the power 98, then in a more simpler language, will I not say that I need to find the coefficient of x to the power 68 in 1 plus x to the power 98? Now, there comes the second part. Can you help me with its expansion? So if I were to write the expansion of 1 plus x to the power 98, I hope you remember, its expansion looks like this: 98c 0, 1 to the power 98, which doesn't matter. Then you write x to the power 0, which is basically 1. I hope you remember it. Then the next term will be 98c1, x to the power 1. Then you write 98c2, x square, and so on, right? So I have this clarity that if I'm looking for the coefficient of x to the power 68, if I'm looking for the coefficient of x to the power 68, then I hope you can relate it that it will be 98c68. It will be 98c68. Are you getting this whole result here? Are you understanding this entire result here? So from here, I can very easily generalize that here the coefficient of x to the power 68 in the expansion of this is going to be 98c68. Did you understand this result? If you have understood this result, I have now the pattern with me. If I begin with this part here, if I look at this part here, in this term, I need to find the coefficient of x to the power 70, but it already has x square. So I'll be finding x to the power 68 in the expansion of this, which is going to be 98c 68. Do you all agree with this? Plus, what about this term? X to the power 70. It already has x cube. So 70 minus 3, 67. So I need to find the coefficient of x to the power 67 in 1 plus x to the power 97, which will be 97 C67. Do you all agree with this on me? So I think we have a pattern. Now after x cube, there is x to the power 4. 4. 70 minus 4. What is 70 minus 4? I hope you know, 66. So now I'm looking for x to the power 66 in the expansion of 1 plus x to the power 96. Well, that will be 96C66. So I hope you must have started seeing the pattern. So here we begin with 98C68 plus 97C67 plus 96C66 up till, let us work on the final term. Let us work on the final term. Okay, so what will be the final term? I'll write the final term here. I'll keep getting these terms. So let me write the final term. I repeat, x to the power 70 is what I'm looking for here. So out of 70, if I subtract 54, what am I left with? I think 54 plus 6 is 7, 60 plus 10 is 70, so 16. So I am looking for x to the power 16 in the expansion of this. 1 plus x to the power 46. So that will be 46C16. Are you getting it? Now, I hope you can see the pattern here. The pattern is very simple. 98C68, 97C67, 96C66. So here, if the last term is 46C16, the second last term must have been 47C17. Do you all agree with this on this with me? I hope the third last term would have been 48C18 and so on up till this term is attained or achieved. Sir, this clearly does not look like this. But if I make you recall something very crucial which we have studied, then are you not able to recall NCR minus 1 plus NCR? I hope you remember, if this n and this n are same and this are consecutive, then we always write this n should be increased by 1 and then take the greater term from here, which is r. Do you remember this result? Okay, sir, that is perfectly fine. But how can we use this property here? Because there I don't see something like that, because for that n and n should be same, but here it is 46, 47 and so on. But mathematics gives you that liberty that you can use things as per your need. You need to balance things out. So balancing is an act which we can do here. What was it? It was 47C17 and then 46C16, right? Okay, I'll use it here. So first of all, I'll be writing that, can I write 46C15 here? Can I add 46C15 here? But of course, if I'm adding it by myself, then I have made an error that I'm adding it. So to add it, I need to subtract it. To do balance it, I'm subtracting 46C15. I hope something is there in your mind. Some of you must have cracked it, that sir, Q is going to be 15. Now, let us proceed further. Here, if you simply look at this part, 46C16 and 46C15, I hope you must remember the result. 46 is common, same. So it will become 47 and they are consecutive 15 and 16. So I'll take the greater, which is 16. So this will be written as 47C16. So this I'll be writing as 47C16. Then again, you need to look at the pattern, and that's exactly what I was mentioning, that the chain gets created. So again, 47 and 47 are same. And here you are seeing 16 and 17 to be consecutive. So this, when added, gives you 48C17. So this gives you 48C17 and so on. So this will keep going on. This chain reaction happens here. And finally, do you not think that when you keep adding, the final term will be here 98C67. When you keep adding and keep bringing this like this. So ultimately, when you add this last term up here, so it will be 98 and 98 are same. So it will result into 99 because 1, it should be increased by 1. And there you have 66, 67 and 68. So the higher number, which is 68. So I should be writing 68. So the expansion which you were writing, or the coefficient of x to the power 70 which you were looking for in this expansion, will be this. and we need not expand it because this is exactly what we are given, 99CP. So I think P is going to be 68 by comparison only. And there you have 46CQ. So Q is clearly going to be 15. So that's a result which you all have received here. But again, there is a certain problem. We have discussed that here 99C68 can also be written as 99C 99 minus 68, and 46C15 can be written as 46C 46 minus 15. So there are four possible answers to this question. I hope you are understanding. By straight away comparing P and Q, I may have said the answer could be 68 and 15. 68 plus 15, because I think we are asked P plus Q. But in the other case, the other answer could have been 99 minus 68, that could also be a value of P, and 46 minus 15, that could be a value of Q. The third answer could have been you take P as 68 but Q as 46 minus 15. The fourth answer could be you take P as 99 minus 68 but Q as 15. So four answers are possible. So whichever answer matches with the options should be marked. I hope you're realizing even if 68 plus 15, let's say, does not match with the options given over here, it may not, then the three other possibilities are also there. I hope you're understanding why. So yes, NCR is NCN minus R. That should also be kept in mind. Did you get this part? How minutely they play with your brain? Because even if you get the answer, you may not see it in the options. You may not. I'm not sure whether it is there or not. And then you may end up saying that whatever you have done could be wrong. But again, there is a catch that there is another formula which you need to remember. NCR is NCN minus R, and that again will help you in getting three more answers. So there could be four answers. And out of those four possible answers, any option could be given in these options. Did you understand this part? Now, with that, let us move ahead. Let us discuss the next part here. What do we see? The next part, which is P plus 1th term in the end, from the end in the expansion of. Basically, after understanding binomial to this great extent, are you not able to conclude that this is such an easy theorem or such an easy concept that you can crack it with simple modification? Let's say what I am asked P plus 1th term from end in the expansion of x plus e to the power n. Now I'll say, why to go in the end and then come back? Why should you do this whole process like this? Can you not use this logic that instead of finding P plus 1th term from the end in the expansion of x plus e to the power n, let us find P plus 1th term from beginning in the expansion of a plus x to the power n. So if I swap x and a, initially I needed to find P plus 1th term from the end in the expansion of this. So we know, rather than like writing it like this, if I could expand a plus x to the power n, so this expansion will have the same P plus 1th term from beginning will be same as P plus 1th term from the end in the expansion of this. Are you realizing? We have already concluded this discussion previously as well, that the coefficient of the first and the last term, second in the second last term, third in the third last term. So by that logic, coefficient will not get hampered at all. And when it comes to looking at the powers, then we know that if I simply swap it, I will get the P plus 1th term from the end only. So I need to look at the P plus 1th term from the beginning in the expansion of this, which will be same as the P plus 1th term from the end in the expansion of this, because there is symmetry. And by using that symmetry, the conclusion is very simple. If you could see that Pascal's triangle being used, or NCR is equals to NCN minus R. These are the properties which will help you in understanding it. Did you understand this result? So keep this result with you. This is going to be used at a lot many times. Just remember it that the expansions are same first of all. Whether you write the expansion of x plus a to the power n or a plus x to the power n, it will be completely same. But of course, if I write it in a specific manner as prescribed by our syllabus or the pattern, the system we follow, then if somebody is asking me P plus 1th term from the end in the expansion of this, then as per the prescribed format, as per the format we follow, then P plus 1th term from the end in the expansion of this will be equal to P plus 1th term from the beginning in the expansion of this, as per the format we follow. I hope you are understanding the catch, as per the format we follow. Otherwise, we all know that these are same. Now, what difference does it make if I write it as, let's say if I'm willing to write a plus b whole cube. So some people write it as a cube plus b cube, then they write it as 3a square b, then they write it as 3ab square. So this is just our way of writing. We need to write these four terms. Now I can have my own way, but usually the pattern we follow is, let's say if I'm writing a plus b whole cube. So the prescribed format is, I'll begin with the highest power of a. So I'll take the highest power of a, then I'll keep reducing the power of a, then I'll keep reducing the power of a. And gradually and simultaneously, I keep increasing the power of b. So b to the power 0, then b to the power 1, then b to the power 2, and then b to the power 3. And then comes the coefficients. So 1, 3, 3, 1. Do you remember that? So if I follow this format, the prescribed format, then of course, the order matters. The first term, second term, third term, fourth term, right? So if in the expansion of this, the second term from the end is this, then in the expansion of b plus a to the power 3, this will be the second term from the beginning. That's exactly what I'm trying to make you understand. So does it make complete sense now? I hope you're able to digest this phenomena, that you need not put all your efforts in finding the p plus 1th term from the end. Rather, in very simple step, you can swap it and find the p plus 1th term from the beginning only. And we all know how to write the p plus 1th term from the beginning, which is ncp p plus 1th term, which means I need to write ncp and in the expansion of a plus x to the power n. So a to the power n minus p, x to the power p. You need not remember this result, you need to remember the logic. And if you understood the logic, I think you can apply it whenever the need arises. Did you get that part? Now, let us move ahead towards the next concept. What is it? Yes, there are problems asked on different concepts. Rather than telling you all these concepts, we'll provide you all these concepts in the notes as well. You can read them there. I will take certain questions, and through questions, I'll make you understand how should you apply. So a lot of cases are there. I'll say, instead of remembering all these cases and the different formulae, just read the question and apply the knowledge you have. Trust me, that is sufficient. How? I'll demonstrate it with this example. What is it? It says the coefficients of x to the power 4, x to the power 5, and x to the power 6 in the expansion of 1 plus x to the power n are in the arithmetic progression. Now, do you need to learn all the other different cases? Can you not interpret or develop your own logic? See, three things are there and they are in AP. And if three things or three terms are in AP, we know the middle term is the arithmetic mean of the other two terms. That's all what I'll do. But before I apply this logic, would I or do I not require those three terms? So let us work on finding those three terms first. What are those three terms? I need to find the coefficients of x to the power 4, 5 and 6 in 1 plus x to the power n. I think that's easy. Why? Because let's say, I hope I need not tell this time and again that 1 plus x to the power n is expanded as nc0 x to the power 0 plus nc1 x to the power 1 plus nc2 x to the power 2 plus nc3 x cube and so on. So whatever is the power of x, that same ncr is there as the coefficient of x. If I'm writing x to the power r, so x to the power r will have the coefficient ncr. I hope you got the logic. The logic is pretty simple. So x to the power 4 will have the coefficient as nc4, x to the power 5 will have the coefficient as nc5, and x to the power 6 will have the coefficient as nc6. Did you understand this part? Any confusions on that? Now, what I know from here is that I very clearly can see this part. Let me just take more lighter colors so that it becomes more visible to you and you don't get confused with this part. So here, these three terms I am told to be in an AP. So these three terms are forming an AP. So if they happen to form an AP, can I say the middle term will be the arithmetic mean of the other two extreme terms? So yes, we can say that double of NC5 will be equal to sum of NC4 plus NC6. You must agree with this. Now, do I know the formula to write the expansion of NCR? We all know. So NC5 I'll be writing as 2 is there. NC5 I'll be writing as n factorial upon 5 factorial into n minus 5 factorial. Any confusions on that? I hope you are getting it. N factorial upon r factorial into n minus r factorial. Now, NC4 I'll be writing as n factorial upon 4 factorial into n minus 4 factorial. Did you get that part? Plus, what about NC6? NC6 again I'll be writing as n factorial upon 6 factorial into n minus 6 factorial. And that's what I'm saying, that you need not learn all the other cases which I was going to explain. In this one shot, what you need to understand is how to find the coefficient and how to use such logics, for example, in an AP. And that's what I'm saying, that binomial is a chapter whose concepts can be used in other chapters as well. For example, here they have merged sequence and series. So that's how they play with the different chapters and they use these concepts all together. So I hope you're understanding. Everything is equally important. That's the crux. Now, let us talk about this part. Sir, how do I deal with this? It's very simple. Why? Because first of all, let us simply get rid of this n factorial. So n factorial, and n factorial. We all can get rid of it like this. Now, what about this? Look at this part. Students, can I say n minus 5? Okay, let me talk about this part first. Here, can I write 6 factorial here? 6 factorial as 6 into 5 into 4 factorial. I hope I can do that. So I'm writing 6 factorial is 6 into 5 into 4 factorial. Is there any confusion on that? Now, what about 5 factorial? We can write 5 factorial as 5 into 4 factorial. Now, why did I do it? Most of you must have noticed that yes, there was a motive behind it. That 4 factorial, this 4 factorial, and this 4 factorial, they are also cancelled. Now, what am I left with? Let me rewrite this part so that you don't get confused. Then I'll simplify it further. Although we can do it here only, but you may get confused. That's why I'm rewriting this part. So this is 2 upon n minus 5 factorial into 5. So 2 by 5 into n minus 5 factorial. Okay, so I'll write it here. 2 by 5 into 1 by n minus 5 factorial. I hope this is what we have here. Any confusions on that? 2 by 5 n minus 5 factorial. And let me check whether it is visible or not. Yes, it is properly visible. Now, it is equal to, I think 1 upon what? 1 upon n minus 4 factorial. Yes, that's great. So it is n minus 4 factorial plus, what do we have next? The next part is, I think 1 upon 30 into n minus 6 factorial. So that is 1 by 30 times n minus 6 factorial. Any confusion on that? I think you are comfortably understanding whatever is written so far. Now, again, I'll use this property that can I write n minus 4 factorial as this n minus 4 factorial as n minus 4 into, I'll run short of space here, so I'll write it in a more shorter format. So n minus 4 factorial I'm writing as n minus 4 into n minus 5 into n minus 6 factorial. Did you get that part? Any confusion on that? Similarly here also, n minus 5 factorial, can I not write this n minus 5 factorial as n minus 5 into n minus 6 factorial? We all can do that. I hope it's visible and understandable. Now, moving ahead, what I can now do is n minus 6 factorial, n minus 6 factorial, and n minus 6 factorial are also cancelled. And now, finally, I'm left with something more interesting. This is 2 by 5 times n minus 5. I hope it is visible. Is equal to 1 by n minus 4 into n minus 5. I hope that is also correct. I hope I'm not making any mistakes. And this is clearly nothing but 1 by 30. So that is what we have received or attained. Any confusions on that? Now, what I do is I multiply, just give me a second everyone. I multiply both the sides by 30 times n minus 4, n minus 5. Basically, I'm taking the LCM, but this is how I do it. So what I'm seeing is n minus 4, n minus 5, n minus 5, 5, 30. So I'm multiplying both the sides by 30 into n minus 4, n minus 5. So 30. So when you do this, or if you are getting confused, I'll do it like this. But please understand, what I am suggesting you to do is multiply both the sides by 30 times n minus 4 into n minus 5. The same I'm asking you to do here as well, that multiply both the sides by 30 times n minus 4 into n minus 5. This is what you should do mentally, but you may have gotten confused. That's why I'm writing it like this, but you should not. You should simply take the LCM and get rid of it. Now, I hope you can see that this n minus 5, 5, 3, 30 is 6, I think. So this is going to be 12 times n minus 4 over here. I hope I'm taking care of it correctly. Nothing wrong is being done here. Now here, n minus 4, n minus 5 cancels this. So here on the right hand side, you're left with 30 here. And then this 30 are cancelled. So this term is where you are left with n minus 4, n minus 5. Any confusions on that? I think this will get converted into a quadratic possibly. So let's write that quadratic formula here. So this is going to be, I think nothing is getting cancelled now. Yes. So it is going to be 12n. This is going to be 48. Right, correct me if I'm wrong. So this is going to be 30. This is 30. Then here you have n into n, which is going to be n square. Then 4n, 5n, which is going to be minus 9n, and 5 into 4 is going to be 20. Just keep checking the conclusions 30, because if I commit any error, I won't be able to correct it or rectify it because I won't realize it at all. So yes, 30 n square minus 9n, and then you have 20. Great. Now, if I take everything there on the right hand side, I'll be left with n square there. Minus 9n minus 12n, right? So 9 and 12, that I think is minus 21n. So that will leave us with minus 21n. Then the next term will be 30, 20, 50. 50 plus 48, 50 plus 48, right? I think I'm going great. 50 plus 48 is 98, I believe. So this is going to be 98. Any confusions on that? I hope there is no doubt, there is no hesitation, and you're comfortably understanding whatever I have done so far. N square, 9 and 12. This is going to be 21, sorry. Yes, I think it is 21. And then because 12 plus 8 is 20, 20 plus 1 is 21. And then 48 plus 50 is going to be 98. Yes, so that's the quadratic we have received. Now, we are told to find the maximum value of n. Nothing else is given. So I think with the options, I could have cracked it. Even if options are not helpful, you need to solve the quadratic. It will give you two values. Out of these two values, the one which is the higher. Of course, both of them should be integral, because integral solutions are expected out of it, because n is basically a power here. So it should be a natural number. So n should be a natural number, and that's what I need to work upon. So if I look at 98, 98 is what I need to look at. So I'll be factorizing 21. So 21 is basically, first of all, to me is, I need to crack 98, right? So let me use the splitting the middle term method. So I'll be writing 98 here. So where do we see 98, right? 98, is it divisible by 13? Because if 98 is divisible by 13, 13 into 7, what is 13 into 7? That I think is 91. No, it is not doable. I think that doesn't work. So 98 is not there in the table of 13. Do we have it somewhere else? Where do we see it? I'll use a simple method here. 98, right? So half of 98 is 49. Half of 98 is 49, right? So this is half. 49 is 7 square. So it is going to be 7 into 7 into 2, right? So 14 and 7. 14 and 7. Yes, brilliant. Perfect, right? So 14 and 7 will help us. I hope you must have realized how did I do it. So factorize it. So it will give me n square minus 14n minus 7n, because it should be plus 98, and that's 98 is equal to 0. I think from here we have learned how to write the roots or the n or the values of n. That is going to be a very simple task. Negative of minus 14 will be 14. Negative of minus 7 will be 7. So n will have two values. I'll get two values of n, which are 7 and 14. Both are perfectly acceptable answers, but we were asked the greater value, the larger value, or the maximum value, which should be 14. Did you understand this part? Even if you get confused, and sometimes if you are not able to split it, so you could have cross-checked it by putting these values, although that would have been more cumbersome, but that is also a method which you can think of. But it was easy here, it was simple here, and I hope it was understandable with this particular approach. Now, let us move ahead towards the next. Again, a category, again, a theorem is given. I'll explain it with an example. Look at this. The question says, second, third, and fourth term. Again, I may tell you the theory and can explain it with an example. Rather, I give you the example and illustrate it so that you get more clarity. Because through these demonstrations, you will be able to understand them more clearly. So here, second, third, and fourth term in the expansion of x plus y to the power n are 135, 30, and 10 by 3. Great. Here, I'll be giving you the complete approach, but I'll not be solving it completely, because the calculation part is where I'll be skipping it. But I'll tell you the whole question, the whole approach. And of course, before I do it, you know how to expand a binomial expansion. You know how to write its r plus 1th term. And through that, you can also think of it. But even if you're stuck, I am there. I'll assist you. I'll guide you. But you are supposed to do it by yourself. But yes, I'll tell you the approach. I'll give you the hint. I'll give you the idea what is needed to be done in this question. First of all, second, third, and fourth. How do you write second term? Second term is T2. So T2 can I write as T1 plus 1? T2 I'll be writing as T1 plus 1. The third term means T3. T3 I'll be writing as 2 plus 1. And fourth term means T4. I'll be writing it as 3 t3 plus 1. So these are going to be the terms. Any confusions on that? What is next? Then the expansion of x plus y to the power n, right? So x plus y to the power n, it will have its expansion as nc. R is 1 here. X to the power n minus 1, I hope you know it, and y to the power 1. Any confusions on that? What about this? Here the expansion will be nc2, x to the power n minus 2 and y to the power 2. What about the expansion here? It will be nc3, I hope you can see it very clearly, x to the power n minus 3 and y to the power 3. Now, this term is told to be 135, this term is given as 30, and this term is given as 10 by 3. Now, the only thing which involves a lot of calculation in this question is that you need to deal with three equations in three variables. First, second, and third. Now, how do you solve this category of questions? That hint I'm going to give you now. See, I have three equations. Let's call them first equation, second equation, and third equation. So my suggestion would be, let us try and get rid of y first. So to get rid of this y, the expression in y, what I'll do is, I will basically multiply these two. I repeat, I'll multiply equation 1 and equation 2. So when you multiply equation 1 into y to the power 1 into y square will give you y cube. And if that product is divided by the third equation, y cube will get cancelled by y cube. First method. Or rather you cube this equation. If you cube the equation 1 and if you divide this by equation 3, again y cube will get cancelled by y cube. By having this, you can get an equation in n and x only. Although it is going to be very lengthy in terms of calculation, but yes, I'm trying to give you the approach here. Similarly, with this and this also, you can get rid of y, because if you square the equation number 1, I'll have y square, and second equation already has a y square. So square of first equation when divided by second equation, y square will get cancelled by y square. Then again, I'll get a term in n and x. I'll get an expression in n and x. So I'll get two expressions in n and x with the help of first and third, first equation, and with the help of first and second equation, where I have eliminated y. So I'm left with two equations in n and x. Now, with these two equations, I'll try to eliminate either n or x. Eliminating x will be easier, mind you everyone. So that's why I'll get an equation in n, and that's how by solving that, I can get the value of n. Once you get n, you can find x, because there was an expression in n and x. And once you get n and x, you put them anywhere in these equations and you can crack the y. What were we asked? We were asked all the three values. So yes, the challenging part here is not to deal with these equations, but to solve them and find the values of n, x, and y, which is a amazingly huge task, because it is going to be a very cumbersome process. It will lie in the moderate category of questions, because by looking at this question only, you will realize that this is doable. But when you start doing it, you will realize that there are three equations, or they are not very simple and ordinary three equations. I hope you're realizing factorials will get involved. The power of x are in variable. So that's where the calculation becomes more confusing. So yes, it is doable, but it will take some time, rather a lot of time. So it should be skipped initially. You should focus on the doable questions, which can be done easily and quickly. And then you should come to this category of questions where you require some efforts. And then there is third category, which is neither understood by you nor you are able to invest some time in them, because you don't understand them. Then how will you be able to solve them? And then you don't have the idea that how much time they'll consume. So basically focus on these two category of questions. First, easy, which can be done quickly. Second, easy, which may take some time, but still they are doable. So easy and quicker ones should be done in the first pass, and then the second pass, easy and then some time consuming ones should be done. These questions, easy and moderate, are always sufficient to make you pass or cross 95 percentile. Trust me, mark my words. Now, I hope this further can be done by yourself. I hope I'm skipping or leaving it up to you. Now let us move to the next part, next category of examples. There we need to deal with the middle terms. Let me go back to the Pascal's triangle. Through that, I'll give you the idea that what do I mean by middle terms. Let us look at this Pascal's triangle. Let us look at this x plus a to the power 4. So when I had the power 4, how many terms were there? When the power was 4, the number of terms were 5. I hope you can see first, second, third, fourth, fifth, although they are the coefficients, but I hope you're understanding it. Out of these 5 terms, when I talk about the middle term, I hope I need not tell you, the middle term will be this one only. So I repeat, whenever the power is even, there is only one middle term. But whenever the power, this is x plus a to the power 5, there is a correction here. This is x plus a to the power 5. So if the power is odd, x plus a to the power 5, the number of terms will be 6, which is even. 1, 2, 3, 4, 5, 6. In that case, if I were to ask you the middle terms, there'll not be just one, there'll be two middle terms. Are you noticing it? Are you noticing and understanding it very clearly? So I repeat, whenever the power is odd, the number of terms are even. And if the number of terms are even, there will be two middle terms whose coefficients will be equal. But if the power is even, the number of terms will be odd and there will be exactly and only one middle term. That's exactly what I am trying to explain here in this particular part where we are talking about the middle terms. I hope conceptually you are able to understand it. Now theoretically I'll give you this idea that if n is even, so x plus a to the power n is even, which means n plus 1 will be odd. So this expansion will have odd number of terms. So out of these odd number of terms, the middle term will be n by 2 plus 1th term. This will be the middlemost term. And if I were to find out the middlemost term, which is n by 2 plus 1th term, it will be n by 2, x to the power n minus n by 2, which is n by 2, a to the power n by 2, which is n by 2. I hope you're getting it very clearly. Now, along with this, second possibility, what if n is found to be odd? So if n is odd, I hope you're realizing the number of terms will be n plus 1, which is going to be even. And if there are even number of terms, we know that the middle term, the number of middle terms will be 2. 2 terms will be there in the middle. I hope you're realizing why. So those 2 terms will be either n plus 1 by 2th term or n plus 3 by 2th term. I hope you're getting it. So by having this, n plus 1 by 2 can be written as n minus 1 by 2 plus 1. So I need to find this n minus 1 by 2 plus 1th term, which is this. I hope you know how to do it. I think there is something wrong here because x is not written over here. So let me just make that correction over here. Just give me a second, participants. Hold on for a while. I'll just make this correction over here. So there you write it as, see, I'm writing t n minus 1 by 2 plus 1th term. So it should be ncn minus 1 by 2 x to the power n minus 1 by 2 into a to the power n minus 1 by 2. This also can be simplified further. It will be 2n minus n plus 1. So 2n minus n is n plus 1. So this can be, in a more simpler language, can be written as n plus 1 by 2. I hope instead of this theoretical concept, you are able to understand how to find the middle terms. I'm not asking you to learn these or crane these formulae. No, not at all. Absolutely not. What you must understand is that if the power is even, the number of terms will be odd, there will be exactly one middle term. Remember it. You know how to find the middle term. You are intelligent enough to do it. And if the power, the n, is odd, then the number of terms will be even and there will be exactly two middle terms, the middlemost terms. That is what you need to understand and remember. And if you have learned that, you can apply it in the questions and get the results. So this is absolutely not what I'm asking you to remember or memorize. Please learn that. Now, moving ahead, there is another concept which is very much loved by IIT JEE, and I am directly giving you the shortcut to find it or solve it. Now, what is that concept and what is the shortcut? Let's look at that part. See, what I'm trying to make you understand here is, let's say there is a binomial expression. Okay. So binomial expression, let's say, looks like x plus a to the power n. And in this x plus a to the power n, I am asked, let's say a is basically a constant. This x is a variable term. And we are asked to write the greatest term where x, that variable, is given a certain value. Let's say I'm told that if x becomes 5, then what will be the greatest term in this expansion? If x becomes 7 by 6, what will be the greatest term in the expansion of this? So there is a standard method as well, which is again a time consuming and standard logical approach that will lead you to this formula only. So people call it a short technique, but I'm calling it a formula which is derived from that standard approach only, that logical approach only. So I'm giving you this direct formula, and this is something you need to remember. This is something you need to memorize. So what we do here in this category of questions, let's learn the problem first, understand the problem first, and then learn what we are supposed to do. So first of all, we are finding the numerically greatest term in the expansion of x plus a to the power n. In the expansion of x plus a to the power n. So first of all, we cannot find the numerically greatest term in the expansion of x plus a to the power n. We can find the numerically greatest term in the expansion of 1 plus x by a to the power n. So to make it look like this, what I do is I take a common. So my expression x plus a to the power n now looks like this. Now what I'll do is I'll try to find the numerically greatest term in the expansion of this. And then I'll multiply it by a to the power n because that will be same. Did you get that part? Now, there, what you need to do is the shortcut says evaluate m. M is a value, a constant, a number. Now, what is m or how to find m? Let's work on that formula. So, to find the m, this is the formula. What is it? It is mod x upon a times n plus 1 upon mod x upon a plus 1. That's it. This I understand and accept is difficult to remember, but if you solve 2 to 3 questions based on this concept, you will have this formula at your fingertips. So I repeat, the question, the concept says, if you are asked to find out the greatest, the numerically greatest, numerically I hope you are understanding, absolute value is what we are talking about. So if you are asked to find the numerically greatest term in the expansion of 1 plus x by a to the power n, then first of all, you need to work on finding m. Now what will be m? M will be a number which will be mod x upon a times n plus 1 upon mod x upon a plus 1. What is x? X will be given in the question that x is either 5 or 7 by 6 or 3 or something like that. So once you have found m, now there are two possibilities. Once you have worked on m, m will be either an integer or it will not be an integer. So if it is an integer, always remember m and m plus 1th term are the greatest term numerically. Or if m is not an integer, then t GIF of m plus 1 will be the greatest term. I repeat, if m is found, then there are two possibilities. M will be either an integer or it will not be an integer. So if it is an integer, mth and m plus 1th term will be the numerically greatest term. Numerically, mind you everyone. And if m is not an integer, then GIF of m plus 1th term will be the numerically greatest term. Now this is what I have tried explaining theoretically. I'll try to give you more clarity about this particular result through an example. Let us solve this question. It will give you a complete, thorough clarity on this concept, which JEE asks. What is it? It says that find the numerically greatest term in the expansion of 2 plus 3x to the power 9, where x is given by 3 by 2. How do we solve it? First of all, what we know is, sir, we know how to find the numerically greatest term in 1 plus. I hope you remember this result here over here. We know how to find the numerically greatest term in the expansion of 1 plus x to the power n or 1 plus x by a raised to the power n. Okay, so can I make it look like this? I can. Possibly by what? Possibly by taking first of all 2 common. This should be 1. You'll have this x as a variable, that is perfectly fine, but here it should be 1. So how do I do it? I can take 2 common. So if I take 2 common, it will look like 2 to the power n times 1 plus 3x by 2 whole raised to the power 9. Now even here it should be x upon a. So to make it look like x upon a, can I not write it as 2 to the power n times 1 plus x upon 2 by 3 whole raised to the power 9. So this now matches with the problem statement we have studied previously in the last slide. A to the power n or anything to the power n into 1 plus x upon a to the power n. Now I know how to find the numerically greatest term in the expansion of this. And that greatest term when multiplied by 2 to the power n will be numerically greatest term in the expansion of this. So I hope we were given something else, we know something else, but with this something else, we can find that which we were asked to figure out by using some arrangements, by using some intuition. Now, how do we do it? This is what we need to simplify or solve or work upon. So let's start solving this. Let us find m. So now my job is to find m. I hope you remember the formula for m was very simple. Mod x upon a n plus 1 upon mod x upon a plus 1. There is any confusion on that? I hope there is no confusion on that. So formula says mod x upon a times n plus 1 whole divided by mod x upon a plus 1. I hope this formula is very well understood by you all. This is which will give me the value of m. Now, How do I put the values? I think we have the values. If I make you compare the values here, please understand this 2 by 3 over here, this 2 by 3 over here is your A. X is what you already have. What is N? I hope you know N is 9. So I think you have everything. X, A, and N, you have all. So X, what is X? X is 3 by 2. So it is going to be 3 by 2. By A, what is A? A is 2 by 3. So I need to take a mod of it, which I need not because it is positive. Times N plus 1. N plus 1 is going to be 9 plus 1, which is going to be 10. Whole divided by mod x upon A again. So again, it is going to be 3 by 2 by 2 by 3, which you could have simplified and written here. If you don't understand it, I'll write it like this so that you don't get confused. Now, I'll write the next part. I am trying to work upon M here. So M is going to be, this I think is going to be 3 into 3, 9, 9 by 4. So this is going to be 9 by 4 and there is no requirement to put a mod over it. So 9 by 4 plus, sorry, it's not plus, it is into 9 into 1, 10, right? Whole divided by, again 9 by 4 plus 1. So this numerator will have 9 by 4 plus 1, right? If I simplify this further, what do I get? In the numerator, I get 9 into 10, which is 90 by 4. I hope there is no confusion on it. And in the denominator, I'll get 9 plus 4, which is 13 by 4. And if I take the reciprocal of 13 by 4, it is going to be 4 by 13. So 4 gets cancelled by 4. So I'm left with 90 by 13. And yes, we know 13 into 7 is 91. Yes, 13 into 7 is 91. So this will be 6.8, 6.9, something like that. So let's say this is 6.8 approximately. I am not calculating it, but I know that this will be 6 point something like that. I am not even calculating that. So why did I do that? Because M is not an integer, but M is 6.7, 6.8 or 6.9, something like that, 6 point something like that. So when M is not found to be an integer, what we know is that if M is not an integer, you find GIF of M. So I'll say here that T of M, GIF of M, which is 6.8, GIF of 6.8 is 6, plus 1 will be the numerically greatest term. Now, can I write the numerically greatest term in the expansion of this? I can. And that I'll multiply with 2 to the power n. I hope you're realizing, because 2 to the power n was there, which we haven't considered so far. We have worked upon this expression only, right? So 2 to the power n is 2 to the power 9 is what I need to multiply here. So I'll multiply 2 to the power 9 explicitly because this is something we have taken outside. We have kept outside to make it look like the standard formula, the standard approach we have learned. So how do I write the m plus 1th term in the expansion of this? 9cm. I hope you know 9cm. So 9cm is going to be 9c6. Then, of course, what do we have next? Then 1 to the power 9 minus 6, which is 1 to the power 3, which is going to be 1, which I need not bother about. Next is x upon 2 by 3. Next is x upon 2 by 3, which is 3x by 2, which is basically 3x by 2. And what was x? X we all know is 3 by 2. So 3x by 2 will be 3 by 2 into 3 by 2 whole raised to the power 6. So this term when expanded, I hope you know how to expand it, will be the numerically greatest term. What I'm trying to make you understand is that you write all the 10 terms of this expansion. And in all the 10 terms of this expansion, you replace x by 3 by 2. So out of all those 10 terms which you are writing in its expansion, the term which is the numerically greatest, which is the numerically largest, will be this, which is the 7th term. Did you understand this part? More importantly, did you understand the approach? That even if ever you were to encounter or solve such category of questions, this is the modus operandi you're supposed to follow. I hope you're able to digest this part. Now, let us move ahead. Let us discuss the next part. What is that? It says that if I were to find the greatest coefficient, you know this part. Trust me, you know this part. This is something we have already been discussing so far. I'll again take you back to the Pascal's triangle we have discussed initially so that you clearly get it in a more better manner. Do you remember, let's say if I talk about x plus a to the power 5 and its expansion, what will you say? You would say that, sir, if you are writing x plus a to the power 5, it is nc0. Sorry, it is 5c0, 5c1, 5c2, 5c3, 5c4, 5c5. Do you remember it? So I repeat, this is nothing but what? This is 5c0, this is 5c1, this is 5c2, this is 5c3, this is 5c4, and this is 5c5. We know that NCR is equals to NCN minus R, and on the basis of that, we have already concluded that 5C0 and 5C5 would be equal, 5C1 and 5C4 will be equal, and 5C2 and 5C3 will be equal. But if you look at their values, will you not agree that 5 was greater than 1, 10 was greater than 5, 5 was greater than 1, 10 was greater than 5, and this 10 and this 10 were equal? Are you noticing something? If you start paying attention on their coefficients, again, if you look at here, 4C0, 4C1, 4C2, 4C3, 4C4. So 4C0, 4C4 were equal, 4C1 and 4C3 were equal, and 4C2 was alone. And even if you look at this part again, 4C0 was less than 4C1, 4C1 was less than 4C2. 4C2 was greater than 4C3 and 4C3 was greater than 4C4. Are you seeing some pattern, a pyramid kind of a structure? I hope you must have started noticing a very good clarity, a very good observation here, which is a very simple statement to say that 5C0, 5C1, 5C2, 5C3, 5C4 and 5C5 will have this relation. So it first of all increases. If I talk about the coefficients, the value increases. It attains its maxima and then starts declining. It decreases. And I hope you must have noticed it attains its maxima exactly in the middle. Exactly in the middle. So if the number of terms in the expansions are odd, you will get only one maximum coefficient. Or if the number of terms in the expansion are even, then you'll get two terms to be the greatest, or two coefficients to be the greatest. I hope you are able to digest the portion which I'm trying to make you understand here through this Pascal's triangle. Let me get back to the part which I was supposed to explain here. Let us get back to this part. So if I'm writing all the terms, for example, let's say I'm expanding and I'm writing all the coefficients. What do I mean by all the coefficients? I'm writing NC0, then I'll be writing NC1, then I'll be writing NC2, and so on, up till the last term. Last term will be NCN. The second last coefficient will be NCN minus 1, and so on. So what is the conclusion we are able to draw? Will you all not agree that, sir, NC0 and NCN will be equal? NC1 and NCN minus 1 will be equal, and it will be greater than NC0 and NCN. Then this will be even greater and more greater and more greater, and in exactly in the middle, you will get the greatest or the largest coefficient. And it all depends. If the number of terms in the expansion are even, then there will be two largest coefficients, they'll be same. And if the number of terms in the expansion are odd, then there will be exactly one middle term which will be the largest coefficient. Are you able to digest this part? And if you are able to understand this conclusion, it is very simple to say now that if n is even, the number of terms will be n plus 1, which means the number of terms in the expansion will be odd. And if the number of terms in the expansion are odd, then there will be exactly one middle term, and that middle term will have this as its coefficient, and it will be the largest coefficient. Similarly, if n is odd, then the number of terms in the expansion will be n plus 1, which will be even. If the number of terms in the expansion are even, then in the middle, there will be exactly two terms. And those terms will have their coefficients as we have already discussed which two terms. The two terms will have their coefficients as NCN minus 1 by 2 and NCN plus 1 by 2. Please remember this. If you are prone to forgetting what I'm saying here, I'll try and make you understand with an example. I'll take two examples so that you get more clarity. Let's say first I take n as even. So let's say I take the value of n as 4, or let's say I take a greater value of n, let's say 10. So what will be the coefficients? 10C0, 10C1, 10C2, 10C3 up till 10C9 and 10C10. Out of these, which one will be the greatest? Don't hesitate in saying if n is even, NCN by 2, which is going to be 10C5. This will be the greatest coefficient. Why? Because I repeat my part here, 10C0 will be equal to 10C10. Then greater than this will be 10C1 and 10C9. Then greater than them will be 10C2, 10C8. And finally, when this pyramid is created, on the top, you will have 10C5 sitting over there. This is the case when the value of n was even, because number of observations, number of terms will be odd. If n is found to be odd, if n is found to be odd, let's say the value of n is odd, any value. Let's take the value of n is 9. So what will I be noticing? I'll be noticing 9C0 and then of course 9C9 greater than these two. These two will be equal. I hope you're realizing. Then I'll have 9C1 and 9C8. I hope you're noticing. Then these two will be equal, but they'll be greater than these two. Then greater than these two, I'll have 9C2 and 9C7 and so on. So finally, there will be exactly two terms in the middle because the number of terms will be even this time. So those two terms will be, I hope you can clearly see it by yourself, that if there are total 10 observations, remove 4 from the front, remove 4 from the end, there will be exactly 2 in the middle and you can crack them very easily. And if you are forgetting it, you can see it by this pattern also, that above this there will be 9C3 and 9C6, and above these two there will be only two terms, which will be, I hope I need not tell, 9C4 and 9C5. I hope you can see 9C, 9 minus 1 by 2, which is 8 by 2, 4. 9C, 9 plus 1 by 2, which is 10 by 2, which is 5. This is exactly what I'm saying, that 9C4 and 9C5 will be the greatest binomial coefficient here when n is 5. Of course, less than this will be these two, less than this will be these two, less than this will be these two, and less than this will be these two. So I hope you are able to understand this pyramid kind of a structure, and then you are able to make some sense out of it. That what do I mean by this largest coefficient or largest greatest binomial coefficient in this binomial expansion? I hope there is no confusion on it. With this particular topic, we are moving towards the second most important chunk of this particular chapter. What you need to understand is that we'll start playing with binomial coefficients now. With binomial theorem, we'll make or do a lot of experiments now. And as a result of these experiments, we'll be getting a lot of series. We'll be getting a lot of expansions in terms of binomial coefficients. So there are certain properties, of course, which we'll be using and learning. And based on that, we'll be dealing with some series based on it. And through differentiation or integration or some experimentations, you will get certain results. And questions are formed on the basis of those results. Of course, we'll start from scratch here only, but you need to pay a lot of attention on this particular part as well, where we'll be discussing a lot of things related to binomial coefficients. So put your complete attention in this particular part as well and stay attentive and alert. Let's first of all understand what do I mean by binomial coefficients. As we have already discussed, NC0, NC1, NC2, NC3 up till NCN. It can also be written as C0, C1, C2 up till Cn. So these are called binomial coefficients, right? So if I were to simply give you a very simple phenomena, a very simple observation, you all must be agreeing with this result that, sir, this is something we have already discussed a lot many times. What is that? That if I look at the coefficients of the term equidistant from beginning or end, then those coefficients will be equal. We already know this particular result, which means NC0, NCN, they'll be equal. NC1, NCN minus 1, it will be equal. NC2, NCN minus 2, it will be equal. And not just equal, but they gradually keep on increasing. I hope you remember this particular result. We have been discussing time and again, and you must have witnessed it in the previous slides and the questions as well. And ultimately, this pyramid gives you the largest coefficient in the middle. I hope you remember this particular result, which is exactly what we are stating over here. So I repeat, if you are expanding 1 plus x to the power n, then the coefficients which you get among those coefficients, if you pay some attention, if you make some observations, then the first observation is this, that coefficients equidistant from beginning and end will be equal. I hope you'll remember it. Let's move to the next learning, next property. What is it? Yes, that's again more crucial. We know what is the expansion of 1 plus x to the power n. We know that expansion of 1 plus x to the power n, nc0 x to the power 0 plus nc1 x to the power 1 plus nc2 x squared up till ncn x to the power n. What if I try and not have this x over here? How can I do that? If I replace x by 1, what will I have on the right hand side and the left hand side? Since it is an identity, right? It is a binomial expansion. So if it is behaving as an identity, and if I'm replacing x by 1 on both the sides, on the left hand side, I'll be having 1 plus 1 to the power n, which is 2 to the power n. But what result will I be getting on the right hand side? I hope you all must be noticing NC0 plus NC1 into 1 plus NC2 into 1 plus NC3 into 1 up till NCN. What does it imply? It implies that it finally boils down to a result that NC0 plus NC1 plus NC2 up till NCN can be replaced or substituted by 2 to the power n. I hope you will remember this as a result. Not just that, this is something which you have or which you may learn when we discuss the concept of set theory. What do I mean by that? Let's say I take a set. Let's say there is a set A, and this set A contains certain elements, for example, 1, 2, and 3. Now, what if I were to ask you about its subsets? Then if I am asking you about its number of subsets, then you may say that, sir, subsets can be created with no element. Subsets can be created with only one element, for example, either 1 or 2 or something like that. Subsets can be created with exactly 2 elements, for example, 1, 2, 2, 1, 1, 3, something like that. Or subsets can be created with all the 3 elements as well. So this is how you could create certain subsets, right? So these are all the subsets it will have. Of course, there will be some more, but I'm just trying to give you an idea. What I am trying to make you understand here in this case is that instead of finding all the subsets, I am more interested in finding the number of subsets. So what will you say? You might end up saying that, sir, the number of subsets could be very simply evaluated, that here I'm having 3 elements. Out of these 3 elements, I may have subsets which won't contain any element. So out of these elements, these 3 elements, the number of ways in which no element can be chosen will be done in 3C0 ways. Or means what? I hope you remember in PNC, or means addition. So yes, there is other possibility that out of these 3 elements, I could have created subsets containing exactly one element. Well, that can be done in 3C1 ways. Or means addition. I could have had 2 elements out of these 3 elements. So a set of 2 elements can be created out of 3 elements in 3C2 ways. Or means addition. I could have created a subset which would have contained all the 3 elements out of these 3 elements, which could be done in 3C3 ways. So this is one of the ways of looking at it. What is the other possibility? The other possibility may or can be answered as, please understand, will you not say that, sir, let us approach this one and ask this one how many choices does this one have? The one will come up and respond saying that, sir, I have 2 choices. Either I'll be a part of the subset or I will not be a part of the subset. Did you get my statement very clearly? So if I approach this one has 2 choices. This one has 2 choices. Similarly, if I approach this 2 again has 2 choices. He'll also say, I'll be either part of the subset or I'll not be a part of the subset. So 2 also has 2 choices in the same fashion, and 3 also has 2 choices. And when I use the word and means multiplication. So 2 into 2 into 2 can be written as 2 cube. Are you not realizing or noticing the same conclusion being drawn here as well? I hope most of you must have understood that this is nothing but what? NC0 plus NC1 plus NC2 up till NCN is nothing but what? 2 to the power n. So this is something which can be proved very easily through set theory as well, the concept of subsets. Rather than calling it a proof, I'll say that this is one of the applications of calculating the number of subsets with the help of this binomial coefficient sum. But I hope you're realizing either I use this method or this, both are equally effective. More important and more crucial is that whether you are able to understand this concept or not, that sum of all the coefficients is always 2 to the power n. Did you get that result? Keep this result with you. You will be using this particular result at a lot of places as per the need. Similarly, there is one more result. Please understand this result. This again is a very crucial one. I hope you understand that here we know that 1 plus x to the power n has its own expansion. But instead of x, let's replace it by -1. What result will I get? On the left hand side, I need not say 1 minus 1 will be 0, 0 to the power n will be 0. But what will I get on the right hand side? I'll be having NC0, then I'll be having minus NC1, because x I have replaced by -1. So whenever there is an odd power of x, I'll be having -1. And if there is an even power of f of x, I'll be having a +1. So this will become plus NC2. Let me make that correction over here. So it will become plus NC2. Then what will I have? Then I'll have minus NC3, then plus NC4, because whenever this even coefficient comes, then it will be positive, and with the odd coefficient, it will be negative. Did you get that part? Now, let us move ahead. What I am now doing is all these terms with negative signs, I am fetching or bringing on the left hand side. So when you do that, do you not think that you have made a very good result, or you have gotten a very good result, that sum of all the odd coefficients, what were they? NC1, NC3, NC5 up till the last odd coefficient. And similarly, sum of all even coefficients, NC0, NC2, NC4, NC6, and so on. So are you not noticing that sum of these coefficients is found to be equal? What I'm trying to make you understand is that if sum of these coefficients is found to be equal, we have drawn a conclusion. What was the conclusion? The conclusion was NC0 plus NC1 plus NC2 up till what? Up till NCN. We have learned that this result was 2 to the power n. Now, amid this result, half of the terms, which are basically odd coefficients, and the rest of the terms, which were the even coefficients, they were what? They were equal. So let's say I call it equal to k. Let's say I call it equal to k for a while. So if I call it equal to k, do you not think here in this expression I'm dealing with k plus k, because the odd coefficients are k and the sum of even coefficients is also k. So I'm dealing with two k's here. So k plus k is basically 2k is equal to 2 to the power n, which helps us in understanding that k will be 2 to the power n minus 1, because 2 to the power n upon 2. So 2 to the power n upon 2 will be 2 to the power n minus 1. All I'm trying to make you understand is that this particular result should also be noticed and understood by you all, that sum of all these even coefficients or sum of all these odd coefficients is going to be equal first of all, and this sum is going to be equal to 2 to the power n minus 1. I hope you will have this result with you. You will remember this as a result. I hope there is no confusion on it. Now, once this particular part is understood, there comes another very crucial result which should be utilized by you whenever you are asked the sum of coefficients in any expansion. Please understand, this is the trinomial expansion. So instead of learning the whole trinomial expansion, applying the whole formula, and then finding the sum of all the coefficients, it's more easy and convenient and doable if you use this particular method. Let's take an example. Let's say in the expansion of 1 minus 2y plus 3z whole raised to the power n, and the expansion of this particular expression, I am asked to write the sum of all the coefficients. So one of the ways is I write its expansion and then I look at the coefficients, and then through some method I find the sum of those coefficients. Second approach, do you not think that whatever its expansion is going to be, if I could simply get rid of those x, y, and z, because the expansions will have the terms in x, y, and z. So if I simply get rid of the terms in x, y, and z, basically the x, y, and z, not the terms, I'll be left with the coefficients only. And if I'm left with the coefficients only, then its sum can be written more easily. And the process of getting rid of x, y, and z is more simple. You don't actually get rid of x, y, z, you replace them by 1. So when x, y, z become 1, they don't appear, they don't seem to be visible there, and that's the advantage of 1 here. So again, if I replace x, y, and z by 1, if I replace x, y, and z by 1, do you not think its expansion will have the coefficients only? I repeat, because the x, y, and z will disappear. They are not disappearing, they are getting replaced by 1 basically. So when you replace x, y, and z by 1, what you get is you basically get the coefficients only on the right hand side and its expansion. So whatever its expansion is going to be, whatever its right hand side is going to be, whatever terms are going to be there in its expansion, the sum of those coefficients can be written very easily if you replace x, y, and z by 1. So on the left hand side, I need to observe a very simple change, that what happens to it when you replace x, y, and z by 1, because it is an identity. So whatever is happening on the right hand side must be replicated on the left hand side. So the result which you are wanting to achieve or attain through left hand side can very easily be calculated through its right hand side. What is it? I'll be replacing x by 1 here, y by 1, and z by 1. So 1 minus 2 plus 3. It is clearly 3 minus 2, which is 1. 1 plus 1 is 2. It is going to be 2 to the power n. So whatever its expansion is going to be, whatever terms are going to be there, since we have replaced x, y, z by 1, on the right hand side, I'll be getting the coefficients only. And some of those coefficients can very easily be calculated by this left hand side, where I've replaced x, y, and z by 1. Can you not apply the same logic in the second illustration we have taken? Here also, why should we bother about the expansion of 1 plus x square whole raised to the power n? Why should you do it? Why should you find its expansion and then find its sum of the coefficients? Why should you do it? Why can't we again simply replace x by 1? And when you replace x by 1, you will have the result with you. Why? Because on the left hand side, replacing x by 1 is a really simple task. And what is the advantage of doing it? Because on the right hand side, I'll be left with the sum of the coefficients only. Because if the terms contained x as well, the x has vanished now. The x has disappeared now because x is replaced by 1. So on the right hand side, I'll again be left with the sum of the coefficients only. Are you able to imagine this? So I'm not even writing its expansion. I'm just trying to visualize this or imagine this, that yes, on the right hand side, the expansion will contain the sum of coefficients. On the left hand side, since we have replaced x by 1, I'll be left with 1 plus 1 plus 1 whole raised to the power n, which is nothing but what? 3 to the power n. Are you realizing how simple and easy it is to calculate something like this if you know such short methods or techniques? I hope you'll remember this as a result and you'll apply it wherever the need arises. With that, let us move to the next concept, or rather the next question. This is a question asked by JEE Mains in 2025. Let's have a look at it and let's understand it and let's solve it together. The question says that the expansion of 1 plus x to the power p, 1 minus x to the power q has the coefficients of x and x square, and they are told to be 1 and minus 2. All right, that's brilliant. And then we are asked to find out the value of p square plus q square. Okay. What I'm doing is, let us write the expansion of 1 plus x to the power p. So how will it look like? I'll say expansion of 1 plus x to the power p will look like p c0, x to the power 0, of course. So here I'll be having pc0 plus pc1 x to the power 1 plus pc2 x square and so on, right? Similarly, what will I get as an expansion of 1 minus x to the power q? Can you help me with this? Since there is a negative sign, so whenever x has an odd power, I'll be dealing with the negative sign. So of course, here also I'll begin with qc0 only. But in the next term, I'll be having minus qc1 x to the power 1. But in the next term, it will be plus qc2 x square and so on until the last term is attained or achieved. Did you get that part? Are you comfortably understanding it? Whenever somebody asks you to find out the coefficients of x and x square, do you not think, let's work on finding the coefficient of x. PC0 when multiplied with this will give you a term in x. Similarly, PC1 when multiplied with this QC0 will give you a term in x. These are the only two ways through which you can get terms in x, and their sum will be the coefficient of x. Similarly, PC0 when multiplied with QC2 will give you a term in x square. Can you see that? PC1 getting multiplied with minus QC1 will give you a term in x square. I hope you can see it happening over here. And PC2 getting multiplied with QC0 will give you a term in x square. And the sum of these coefficients will also be nothing but the coefficient of x square, which is also what we are given. Any confusions on that part? What you all must realize is that other than this, I won't be having any term in x and x square. There could be either coefficients of the lower degree of x or the higher powers of x. Because when PC0 gets multiplied with QC0, what I'll be getting is x to the power 0, which I need not bother about. Or even when I proceed further, I may get the higher values, higher powers of x, x cube, x to the power 4 or something like that, which also I need to worry about, which I need not worry about because I am dealing with x and x square only. So I hope the requirement is very well conveyed and understood. And let's start working on it. So I'll be using the first result first. What is it? The coefficient of x. So coefficient, acha, let me write it more clearly. PC0 we all know is 1. PC1 is p, and PC2 is nothing but what? It should be p minus 1 divided by 2. Any confusion on that? Times x square. I'm really sorry. Times x square. And of course so on, but those terms don't matter to us. Similarly, when you talk about QC0, it will also be 1. QC1 will be Q. I hope I'm writing it all correctly. And plus QC2, it will be Q minus 1 divided by 2 times x square and so on. Right. Now let's start working on the comparison of coefficients. So if I simply start with the coefficients of x, it will be given by px into 1, that will be p. And next will be minus qx into 1, that will be minus q. So p minus q I received as the coefficient of x, which I am told to be 1. So p minus q we have evaluated as 1. Let us look at the other coefficient now. x square's coefficient. So px into qx, or rather I'll begin with this 1 into this, that will be q minus 1 whole divided by 2. That's your first coefficient of x square. Let us be more systematic so that we don't miss any term. So next is px into minus qx. So that is minus pq. Let me write this minus pq over here. Next coefficient of x square will be this into 1, which is p minus 1 by 2. So this is plus p minus 1 whole divided by 2. That's your expansion, and that's the coefficient of x square, which we are given as minus 2. I hope this part is very well understood by you all. Let me try and simplify this, and let's see what result do we get. So first of all, I am multiplying both the sides by 2 so that we can get rid of this 2. All right. So when I'm multiplying both the sides by 2, what result am I receiving is that the result we are receiving is q square minus q. All right. So we are receiving q square minus q. Then what do we receive next? Minus 2pq. I hope you know why. So minus 2pq. And then what I receive is p square minus p. So there I receive p square minus p is equal to, it was minus 2, but we have multiplied both the sides by 2. So it should become minus 4. Any confusions on that part? I hope this is understandable. Now, the next conclusion which we all must have seen is p square plus q square minus 2pq. I hope you all can see it very clearly. It will be p minus q whole square. It could have been written as q minus p whole square also. That doesn't matter. So I can write it anyways, either ways. So here it is going to be p minus q whole square or q minus p whole square. That is what we have attained with the help of these three terms. And minus q and minus p, if I take negative sign common, I'll be left with p plus q is equal to minus 4. Any confusions on that? Now, what was the value of p minus q? We have already evaluated p minus q was 1. So if I use this result, p minus q was 1. So I'll replace 1 here. So it is 1 minus of whole of p plus q is equal to minus 4. So this 1 goes there, it becomes minus 1, minus 4, minus 1, minus 5. So it is going to be minus of whole of p plus q is minus 5. So can I conclude p plus q is going to be 5? We have gotten this as a result. So p plus q is 5 and p minus q is 1. So if I add both of these equations, I think I'll get the values of p and q. If I add both of them, 2p will be 6. So it means p is 3. So if p is 3, q will be 2. I hope you have understood these two results. So we have gotten the values of p and q, right? If I know the values of p and q, which are 3 and 2, what were we asked? We were asked the sum of their squares. So 3 square is 9, 2 square is 4, 9 plus 4 is going to be 13. Did you get this result? Did you understand the solution? More importantly, did you understand this part? How did we compare the coefficients? How did we evaluate this particular part, that how are we going to get the terms in x? How are we going to get the terms in x square? And how did I use this simple comparison? And by solving these two equations in p and q, we simply worked out the values of p and q, and we could write p square plus q square. That was a very simple and easy task, and I hope most of you must have been able to understand this result. Did you get this part? Of course, make it a habit, make it a practice that while we solve questions as teachers, you also pause the screen and do it by yourself so that you can also assess or evaluate how much you are able to comprehend and understand. Not just that, even if you're not pausing the video, you solve it simultaneously along with this. Even if you're stuck, of course, you can look at the screen and watch the solution. And even if you have some other method, then of course, you can come up with your approaches. We would love to hear it from you in the comment box. Let's say if you are using some other method and have gotten the result, then do share it in the comment box. Why? Because it helps us in understanding that there is some other method, and it helps us in understanding whether you're using the right method or not. Sometimes what students do is they may end up getting the answer 13, but through a wrong approach. And of course, you cannot claim that your answer is right. Figuratively, it is right, but that answer is not correct, because in the real examination hall, if you're using that wrong method, coincidentally, the way it has happened here, you may not get the right figure there with that wrong method. So that's when, if you're using a different method and if you're coming up with the same answer and believing that you are having the right approach, please ensure that it is actually right. So there are two ways. You are actually a very intelligent person, which we all don't know whether we are intelligent or not. How can you call yourself an intelligent person if you don't know yourself? We all cannot, because there is some supervision required. So if you believe or feel that if you have used some other method and through that also you have gotten the right answer, then do write in the comment box that this is something which you have done. We'll evaluate it and we'll tell you, yes, that is also something which can be used. And if it is more effective and efficient, do share it with us. We'll really appreciate it. I hope you're understanding the intent. Now, moving ahead clearly with this particular example, let us go ahead. Let us see some other set of questions. Again, this is a category which I'll be explaining through a question. This category of questions are also seen lately or recently these years, where you need to deal with the integral and the fractional part of a binomial expression. A number is given, usually irrational and rationals, sum or difference, and that's how you're asked its fractional or integral part, and there you need to work upon it. So there is a very standard process which you need to follow on this category of questions. There is a standard method, predefined set of rules which you need to follow, and you'll get the answer. So don't ever worry about that particular result. What you need to understand is that what is that method, how should you apply it, and how should you get the answer. So instead of telling you again the entire theory, the concepts, I'll be taking an illustration, I'll be taking an example, and through this I'll be clearly giving you the idea that how should you deal with questions based on binomial expansion or theorem, where you are asked to deal with questions based on integral part or fractional part or something like that. How do we deal with it? Let's read this question first of all. So this was a question again asked by JEE in 2023. In recent years, they have been asking such more category of questions. So there could be a question based on it. Again, there is a very high possibility of this category of question popping up in your shift of JEE mains. Now, in advance also, they are using this particular concept very, very, very affectionately. Now, okay, so let's look at this particular part. 8 root 3 plus 13 to the power 13. That's a number. Now that will be a number. And then again, you have a number 7 root 2 plus 9 whole raised to the power 9. And these numbers GIF are taken, and then we are asked about our opinion that whether it will be even or odd. So we, of course, will try finding our solution, our approach. But before I do it, let us understand the approach. So I'll be doing certain things. I'll be applying certain concepts altogether. So there is a step-by-step process. In that process, initially, you may not get this conclusion that why are we doing all this? Have faith in your trainer, have faith in your teacher, and just follow the instructions with complete dedication and faith. And once I make you understand the entire process, the entire solution, then you will be able to draw a conclusion that in step 1, why did I do something like that? In step 2, why did I do something like that? So initially, you may not be able to see things happening over there. But once the entire solution takes place, once the entire solution is done, you will be able to connect the dots more easily. So this time, I'm hoping that you are having a lot of patience and you'll be understanding the whole steps one after another, and then only you'll be asking questions, right? So just look at the whole solution first. Can we get started with this particular part? Yeah. So let's forget y for a while. Let's work on x first. So this process I'll be repeating twice. First, I'll begin with is x. I'll do this whole process once, and then I'll repeat the same process again with y. And that's where you have the opportunity that once you have understood the whole process on x, you may do the same process on y by yourself as well. Now, let's work on x here. What is x? X is given as 8 root 3 plus 13, whole raised to the power 13. But let me put my focus on this number, 8 root 13 plus 13. So that is something we are given, right? 8 root 13 plus 13. All right, that's brilliant. That is perfect. That is great. Now, let me find its conjugate. So first of all, there are two things. 13 and 8 root 3. Which one is greater? So to find out which one is greater, what I'll do is I'll write 8 root 13 and 13, right? Out of these two, if I'm willing to find which one is greater, of course, we know root 3 is 1.732. And of course, 1.732 into 8 can be a number, which is a little tricky to find out because 1.732 into 8 and then 13, comparison may be very close. What we know through inequalities is that whatever sign is there between them, even if I square both of them, the sign of that inequality won't change because both of the numbers are positive. So why couldn't I square it? Let's do it. So 8 root 3 when squared gives you 64 into 3, and 13 square we all know is 169. I hope there is no confusion on it. 60 into 3 is 180. 180 itself is greater than 169, and 4 into 3 is 12. So 180 plus 12 is 192. So 192 we all know is greater than 169. So if 192 is greater than 169, 8 root 3 will be greater than 13. That's brilliant. So we have the right order. So if one of the numbers is 8 root 13 plus 30, I am taking the other number as, the other conjugate of it as 8 root 13 minus 13. I hope you are getting it very clearly. Now, imagine that this is a number. This is a number. Let's imagine this as a number. Let's try and work out its product. So if I'm multiplying this irrational number with its conjugate, let's see what is the product we get. Sir, why are you doing all this? I hope you remember the disclaimer. Just observe what I'm doing right now. Don't ask any question at this stage. Just look at all these steps. Once you have understood all these steps, you'll be able to understand, why did I do this? Why did I do that? Why am I doing all this? And what am I going to do all the steps next? That all those steps will all make a complete great sense. But first of all, observe and analyze. The second step is going to be pretty simple. I hope you all can notice it very clearly here. It is a plus b into a minus b. We know it is going to be a square minus b square. So what is a square? 8 root 3 into 8 root 3, we already know, is 192. It is going to be 192 over here. And 192 minus 13 into 13 is 169. So that is going to be 169. I hope there is no confusion on it. Now, when I move ahead, when I proceed further, it is going to be 8 root 30, 8 root 3 minus 13, which is equal to 192 minus 169. So 169 plus 1 is 170. 170 plus 20 is 190. So 213. So that is 23. So it is going to be 23. And below this 23, I'm taking this factor here, which is 8 root 13 plus 13. Now, why am I doing all this again? Please don't ask any questions. Just look at all what I'm doing. Since we have skipped the theoretical part where I could have made you understand this particular result, and then we may have moved to this illustration part, but it would have consumed a lot of time. And in this one shot, I'm trying to make you understand that whole process of solving this category of questions through this illustration only. That's why have some faith and patience and just observe what I'm doing. Now, what I'm trying to just get some clarity upon is that what do we know about this number 8 root 13 minus 13? So 8 root 3 plus 13 is going to be what? It is 13 already. Even if root 13 is 1, so 1 into 8 would have been 8 and 8 plus 13 would have been 21. But it is somewhere, let's say root 3. Root 3 is greater than 1.5 because root 3 is 1.7. Even if I take it as 1.5, which it is greater than 1.5, but even if I take it as 1.5, 8 into 1.5 would have been 12 because 8 plus its half, 1.5 means what? So it would have been 12, and 12 plus 13 would have been 25. Although we know it will be greater than 12 because it is 1.7 basically. So if numerator is 23, denominator is more than 25, let's say 25 for a while. So 23 upon 25 will be less than 1. Will be less than 1. I repeat, it would have been less than 1. So what I'm trying to make you understand is a very important result. That 8 root 13 minus 13. Of course, this would have been a positive number as we have already discussed and evaluated here. But if I am seeing that 8 root 3 minus 13 was between 0 and 1, 8 root 13 minus 13 will be between 0 and 1. So whenever you are asked this category of questions, their conjugate have this chances of lying between 0 and 1. They have very high chances of lying between 0 and 1. But of course, you need to verify it. You need to validate it. Now, why are we doing all this? Please don't ask at this stage. Just observe and analyze. So here, what I have been able to conclude is that if 8 root 3 plus 13 is a number, then there is another number which is 8 root 3 minus 13. And the beauty of this number 8 root 3 minus 13 is that it will be a fractional number because it will be between 0 and 1. Did you understand this particular part? Any confusions on that? So I know something now. Okay. So if I know something, let's say there was a number 8 root 3 plus 13. There is another number 8 root 3 minus 13. Right. What I know is that this will be a number, that will also be a number. This number, let's say if I'm raising to power 13, it of course will be a number which I'm given as x, right? And here I'm dealing with another number and I'm raising this also to the power 13. And I hope I need not explain this particular part where I say that if this number, this particular number lies between 0 and 1, it is raised to the power 13, that it will also be lying between 0 and 1. Because a number which is lying between 0 and 1, if it is increased to higher powers, it will become even smaller. So this will also be a number which will lie between 0 and 1. So let me denote it by x dash. Let me denote it by x dash. And we know x dash will be a number which will be basically a number lying between 0 and 1. So here I have drawn a conclusion that x dash is basically a number which I need to remember is going to lie between 0 and 1. Can we do that? Can we keep this thing in mind? So this is the crux of whatever we have discussed so far. So all what I have done previously should be done by you also. But out of all of this, what I have done, this is the crux I have come up to. Did you get this part? The same I'll be doing with y as well, but as of now, let's focus on x. Sir, why did you do all this? Forget it. Can you help me with its expansion? The expansion of x and x dash. I hope you must have remembered that expansion of x and x dash will be very simple. And if you notice something, let me write the expansion of x. What will it look like? The expansion of x will look like, I hope you know NC0. So I'll begin with 13C0. So 13C0, x to the power 0. So 8 root, I hope you remember, 8 root 13 to the power what? 13 minus 0, which is 13. So I'll begin with this part where I'm writing 8 root 3. Let's forget that x, 8 root 3 to the power 13 times 13 to the power 0, which I need not write. Then the next term will be 13C1 and 8 root 13 to the power 12. So 8 root 13, sorry, it's not 8 root 13, it's 8 root 3 to the power 12 times what? Times 13 to the power 1 and so on, right? This part I'll be writing here. We know that x dash lies between 0 and 1, right? So let's keep it here. Now, this is how it will go on and it will be there until the last term is attained. Can you help me with x dash? Can you help me with x dash? Most of you must have noticed and cracked that, sir, x dash will be completely identical to x. The only change will be that here, whenever you are having the odd powers of 13, there will be a negative sign before that. Okay, so let's write that expansion. So here also you will have x dash, which is 13C0. Then you have 8 root 13 to the power 13. Then you have 13C1, but here before 13C1, I'll have minus 13 to the power 1, which will put a negative sign over here. So it will be 13C1, then 8 root 3 to the power 12, and then you have 13 to the power 1, and so on until the last term is attained. Did you get this part? Now, why are we doing all this? As disclaimer is already given to you. Don't ask any question at this stage, just observe what is being done. Now, let us try to get rid of the irrational terms. So either I could add x and x dash, or I could subtract x with x dash from x dash. But if I'm willing to get rid of the irrational terms, what should I do? Can I have your opinion right now? So most of you must be saying, sir, see, whenever root 3 has an even power, you are getting the rational terms. But whenever root 3, this was not root 13, this was basically root 3. Let me correct that. So this was root 3 here. So it was 8 root 3. So whenever root 3 is having an odd power, that is still staying or remaining as an irrational term. So if you subtract this, if you subtract x dash from x, you may get something really crucial from here, which is that you will have the irrational terms getting eliminated. What do I mean by that? Let me write that result. So on the left hand side, I'm subtracting x dash from x. So on the left hand side, I'll be having x minus x dash. Now please pay attention. See, this and this are identical. So if I'm subtracting this from this will get cancelled. This will get doubled. So basically, I'll get terms getting doubled because this and this are identical now. And if it is subtracted, minus of minus is plus. So this plus this, which means double of it. What is getting doubled? All the rational terms are getting doubled. In a more clearer language, calling them rational, I'll be calling them integral terms, because see, this is going to be a purely integer number, because 8 root 13 to the power 12 will be an integer, 13 to the power 1 will be an integer, 13C1 will be an integer. So what do I mean by that? All of these terms are going to be integral terms. I hope you are able to understand my conclusion very clearly here. So what I'm trying to make you understand is 13C1 will be an integer, because the number of ways in which one object can be selected out of 13 objects will be a number, will be a number which will be a cardinal number, which means it will be 1 2 3 4 something like that. So it will be a natural number or a whole number most probably. So a number, integer into integer into integer will be an integer. So integer plus the same integer will be double of that integer. So basically all the irrational terms are getting cancelled by this subtraction, and I'll be left with something double of integer. So can I say this will be double of an integer rather than writing all these numbers? Because that is something I'm not interested in. Rather, I'm interested in something more crucial and important. What do I mean by that? Please understand, from here, can I not write that x is equal to 2 into an integer plus x dash? Okay, I'll talk about this x dash later, but what do you mean by 2 into any integer? Whenever you multiply any integer with 2, whatever this integer was, even or odd, but if you multiply this integer with 2, do you not think it will become an even number? So I am writing 2 as, so I'm writing x as an even number, an even integer plus x dash. Do you all agree with this? And rather than calling it an integer, since all the numbers were positive, I'll call it an even natural number. I'll call it an even natural number plus x dash. Now this is how, or this is where your question is done if you have paid attention to the conclusion we have drawn. Why and how? Let's talk about that now. The conclusion is pretty simple here, students. Please understand, x is nothing but an even natural number plus x dash. What was x dash? Sir, x dash was a number between 0 and 1. I'll try and make you imagine. For example, let's say x can be taken as an even natural number. Take any even natural number. Let's say 4. 4 will be a very small number. It will be greater. Let's say 142. Plus, take any number between 0 and 1. Let's say 32. So let's say, just to make you understand, I've taken x as an even number plus a fractional number between 0 and 1, which is 0.32. Can you not help me with its GIF? Its GIF is going to be 142. Well, I'm not asking you its GIF. I'm asking you whether it will be even or odd. So since x is already an even natural number plus x dash, do you not think its GIF is going to be an even number? So first of all, we are able to conclude that yes, GIF of x is going to be an even number. Now the second part of this question. So here you can pause the video and do the next part of the question by yourself. Although the second choice is you can keep solving it simultaneously along with this video. Third choice is, if you got confused with whatever I've done so far with x, you can watch the same process getting repeated on y now. And that's how you can develop a complete great clarity on this y and this process and this method. The modus operandi which I'm trying to make you understand. More importantly, those who have been able to understand this particular result, are you getting it more clearly now that why did I do all this? Why did I do all this? So I'll be repeating the same process for this number y now. Let's focus on y. Y is 7 root 2 plus 9 whole raised to the power 9. Okay, 7 root 2 plus 9. So let me look at a number 7 root 2 plus 9. First of all, I need to work upon 7 root 2 and 9, and I need to evaluate which one is greater. So out of 7 root 2 and 9, if I wish to find out which one is greater, because root 2 is 1.4. Even if you multiply 7 with 1.4, you can evaluate it very quickly. But if you get confused with multiplication with these numbers, even an easier approach is square both these sides. So 7 square is 49, root 2 square will be 2, and 9 square is 81. 49 into 2 is 98. 98 is greater than 81, so 7 root 2 will be greater than 9. So they have given us the correct order, greater plus lower. So yes, if this is a number, the other number can be taken as its conjugate, which is 7 root 2 minus 9. So I had two choices. I could have written it like 9 minus 7 root 2 or 7 root 2 minus 9. So I am basically writing it as 7 root 2 minus 9. It will help us in being more clear. Although no problem would have occurred even if you take 9 plus 7 root 2 as well. Now, let's look at this particular part. Which part? Here. What is going to be the product here? So 7 root 2, a plus b, a minus b is going to be a square minus b square. So 7 root 2 into 7 root 2 will be 49 into 2, which is going to be 98 minus 9 into 9, which is going to be 81. Can you help me with 98 minus 81? It is going to be 9 and 8, I think 17, right? So yes, this is going to be 17. So the difference is going to be 17. I hope there is no confusion on it. 7 root 2 minus 9, can it not be written as 17 divided by 7 root 2 plus 9? Did you get this part? Now please understand, 9 plus 7 would be 16. And root 2 will make it, 7 root 2 will be greater than 8 at least. So 9 plus 8 would have been 17, and we know the denominator is greater than 17. I hope you can understand this part. So if denominator is again greater than numerator, that means the fraction is less than 1 because both are positive. So again, can I not conclude that 7 root 2 minus 9 was of course positive, so it will be greater than 0. But we know here that here, by observing it like this, I can conclude that here it will be less than 1. So 7 root 2 minus 9 will again be a number which will be a number lying between 0 and 1, a fractional number less than 1. Same process. I hope you are making complete sense out of it now. What was y? Let's look at y. Y was 7 root 2 plus 9 whole raised to the power 9. So y was given as 7 root 2 plus 9 whole raised to the power 9. I'm assuming another number y dash, which I'm taking as 7 root 2 minus 9 whole raised to the power 9, where we know that y dash is a number which lies between 0 and 1. Did you understand this particular part? Did you get it completely? Any confusions on that? Now, let us move ahead. Let me write the expansion of y. So y will look like, I hope you know it very clearly now, it will look like nc0, 9c0, 7 root to the power 9, and of course 9 to the power 0, plus 9c1, 7 root 2 to the power 8, and 9 to the power 1, and so on until the last term, which I'm not writing here. What about y dash? I hope most of you must have cracked it by now that y dash will also be same, except for the part where the odd powers of 9 will have the negative sign. So I'll be writing it as 9c0, 7 root to the power 9 minus 9c1, 7 root to the power 8, 9 to the power 1, and so on. Most of you must have generalized this step as well, that this step or writing the step is completely useless. What you need to see is, or notice it, that through which terms you are getting the rational terms and through what powers you are getting the irrational terms. If you start noticing that, if you have noticed that, you would be able to conclude the next step directly. You need not write this entire step here. I hope most of you must be able to understand what I'm trying to say here. So can you tell me now that should I add it or subtract it? What do I want? I want the irrational terms to be eliminated. How will I get rid of it? So here, when you see odd powers are giving you irrational terms and even powers are giving you rational terms. What do I want? Do I want irrational terms? No. What do I want? I want the rational terms. So to eliminate the irrational terms, I hope we can clearly see that I need to subtract it. So from y, I'm subtracting y dash. So if y dash is subtracted from y, what do I get? Again, see, this minus this, both are identical 0. So all the odd powers of 7 root 2 will get cancelled. All the even powers of 7 root 2 will be doubled. So again, do you not think I'll be getting double of an integer, or more clearly, double of a natural number? Again, most of you must have been able to conclude the answer directly at this stage. If you are not, let me write it more clearly. Y is basically 2 into a natural number, which is what? An even natural number plus y dash. What is y dash? A fractional number less than 1. So if I were to ask you, what about the GIF of y? What would it be? Again, you need to imagine something like an even natural number plus something decimal. It will be, its GIF will be, its integral part will be an even number. Do you all agree with this me? Now, so if GIF of x was even, if GIF of y is even, now let us conclude what can be said. I think option B, C, D are absolutely wrong because one of the parts of them is wrong, but even D both are wrong. But option A, since GIF of x and GIF of y are even, then their sum should also be even because sum of two even numbers is even, and in that case, I would have marked very easily option A. Did you get complete clarity on it? Are you able to digest this particular result here very clearly? Now, if this part is understood, let us move to the next part. What are we given here? So I hope it makes complete sense. You are able to connect the dots, the entire process, the entire method. And there we see a question on remainders. So to solve this category of questions, you have your own approach of binomial theorem. You can use it. But there is one more method, which is a shortcut, you may call it, but it helps you more effectively and efficiently if you use questions, if you use it on the questions based on remainder, especially with this category of questions, when you are asked to deal with remainders on this power-based category of questions. How do you develop that logic or that trick or that technique for such category of questions? Let's work on that particular result. For example, what you need to understand is a very simple conclusion. What is that? See, let's say I have a number 19, then I have a number 7, and then let's say I have a number, let's say any number, let's say 5. So it would be a number. What would it be? It will be 19 plus 7 minus 5. It will be a number. And I'm asked to divide it by, let's say, 4 for a while. And I'm asked the remainder. I'm not asked the quotient. I'm asked the remainder. Now, how can I find it? One of the ways is I find the sum and then subtract 5. So 19 plus 7 minus 5. 7 minus 5 is 2. So 19 plus 2 is 21. So what I could have done is remainder when 21 is divided by 4. So we know 5 times of 4 is 20, which basically leaves us with the remainder 1. Did you get this part? Now what I'm trying to make you understand is it is perfectly fine. What is also fine is that you divide them individually and then take those remainders and put the same sign between those remainders. Sir, why should we do it like this when this is an even simpler method? As of now, just learn it. For the sake of learning, learn it. I'll tell you why would it be more convenient in solving this category of questions. Let me get back to this particular result. So what I'm suggesting here is 19 upon 4. So 4 into 4 is 16. 19 minus 16 is 3. So from 19, I'll get a remainder 3. Then what is the sign here? Plus. Then 7 upon 4. 4 into 1 is 4. Again, the remainder will be 3. Then 5 upon 4. I hope you understand that 5 when divided by 4, 4 into 1 is 4. Remainder is 1 because 5 minus 4 is 1. So I am left with 3 plus 3 minus 1. So 3 plus 3 is 6. 6 minus 1 is 5. Now look at this, sir. You got the wrong answer because this is 5 and this is 1. Have faith in the process. Whenever you see a number which looks like a remainder, and if it is greater than the divisor, then we know a remainder cannot be greater than the divisor. If you are dividing a certain number by a 4, the remainder will be either 0, 1, 2 or 3. It cannot be 4 or greater than 4. So whenever you get a remainder greater than the divisor, you again divide it. So let's say I'm getting a remainder 5, which is not wrong mathematically. But as per the definitions and theorems you follow, 5 cannot be accepted as a remainder when a number is divided by a 4. So what I do is, if I get a number as a remainder which is greater than the divisor, then I redivide it by the same number. So 5 I'm redividing by 4, and let's find the remainder now. So I think now the remainder is going to be, I hope I need not tell you, 5 by 4, the remainder will be 1. And that one and this one is same. Are you able to understand a process here? The process which I'm trying to make you understand. Now let's get back to this question. What does it say? The question says 64 to the power 64 whole raised to the power 64. So first of all, to me it looks like 64 raised to the power 64 into 64. Did you get this particular part? Any confusions on that? I hope there is no doubt or no confusion here. Now, please understand, this 64 is basically written 64 into 64 into 64 into 64 how many times? 64 into 64 times. Are you getting my statement very clearly? Now, this is needed to be divided by 7 and then we need to find the remainder. Okay, great. Now, let me rewrite this part here, that here in the numerator I have 64 into 64 into 64 a lot many times it is written over here. If I were to just give you the idea, it is written how many times? It is written 64 into 64 times. So how many times is it written? 64 into 64. It doesn't matter much, but still it needs to give me the idea whether it is written even number of times or odd number of times. I'll tell you why and how. And this entire number is needed to be divided by 7 and then we need to find the remainder. What did we learn through a different method which I have tried teaching you as a shortcut or a short technique? The method was pretty simple. Divide these numbers individually by 7, and among those remainders, use the same sign, the sign which was here. Either it will be either plus, minus, or product. These three signs we will be working upon. So, what I'm trying to tell you is that 7 into 9 is 63. I repeat, 7 into 9 is 63. So 64 minus 63 is 1. 64 minus 63 is 1, which means I got a remainder 1 from here. I tried to look for a number which is very close to a multiple of 7. So the best thing which has happened is 7 into 9 is 63. And they will ensure that a number is given to you which will be close to a multiple of this number. For example, here 7 into 9 is found to be 63. And 63 is just 1 less than 64. Perfect. The game is over. Why? Look at this. 64 minus 63 is 1, which means 64 when divided by this 7 will give you a remainder 1 into. What about the remainder over here? This 64 also, this 7 is into 9 will give me 63. 64 minus 63 is 1. So I'll be getting 1, 1, 1, 1, 1. All the remainders will be 1. With each number, the remainders are going to be 1. With each number, with each of these 64s, the remainder is going to be 1. How many times? I'll say 64 into 64 times. Well, it doesn't matter as of now because 1, no matter how many times multiplied with itself, gives you 1 only. Gives you 1 only. And in that case, I'll say the remainder is 1. Did you understand and realize how simple it is if you use it? So let's say, had there been some other number as well as a product of this, and let's say I could have gotten a number greater than 7, then what would I do? I hope you remember, if you receive a number which is greater than 7, it cannot be the remainder in that case. Then redivide it by 7, then again divide it by 7. So as long as you're not getting a number less than 7, you keep dividing it. Why am I saying this? You need to understand that remainder is a very interesting concept. We are taught remainder in a very specific manner, but it has its own beauty. What I'm trying to make you understand is, let's say I'm dividing 34 by 7. I'm dividing 34 by 7. So what are the other methods? Some of you will say, sir, the standard method says that 7 into 4 is 28. So 7 into 4 is 28 and 34 minus 6 is 28. So in that case, we say that here, minus sign is not there. So in that case, we say that the remainder is 6. I hope you're understanding it. Why? And here, the remainder is 6 when 34 is divided by 7. The other person could have said that, sir, let's say here 34, I'm willing to divide that by 7. And I don't read 7 up to 4 times. I say 7 I'm reading up to 2 times only. And 7 into 2 is 14. So 34 minus 14 is what? It is 20. Now the problem is, can you say that this 20 is remainder? Technically, it can be a remainder, but mathematically, theoretically, conceptually, if I say that 20 cannot be a remainder because the remainder has to be less than the divisor. So if I have gotten a remainder which is greater than the number, then again I'm further supposed to divide this number by 7 until I get a remainder which is less than the divisor. So I hope you are understanding the concept of division here. There is another concept which is called negative remainder. Now what does it mean? Let me try giving you clarity through that particular example. Let's say here, instead of dividing 34 by 7 like this, let's say I read 7 into 5 is 35. But how can you read it like 7 into 5, 35, since the dividend is 34 only? Have faith in me. 7 into 5 is 35. So 35 is what I've gotten. 34 minus 35. What I've received is minus 1. What I have received is minus 1. Sir, how can you say that the remainder is minus 1? Take it as a minus 1. Sometimes minus 1 will also be very much useful in your questions. How? Let us change this question a little and then again try and solve this. This question was 64, 64, 64. Okay, let me change this question. I'll be taking a question 7 into 9 was 63, right? 7 into 9 was 63. Okay, I'm taking a different question. I'm taking an example to make you understand. Let's say 62 to the power 69. I need to find the remainder when 62 to the power 69 is divided by 7. What will be the remainder? That's the question. Did you understand the question? Let's say we are given a question where we are given 60 to the power 69 and we need to find the remainder when this is divided by 7. One of the methods is use binomial theorem. I am perfectly okay and fine with that approach. I have no issues with that. But here, please have faith in me. You can use this short technique as well and get the results. Although we'll be explaining the binomial theorem as well, don't worry about that. But this short method can also be used. So yes, let's try and utilize this particular result. How can we have this result over here? See, basically I'm having 62 written how many times? It is written 69 times. Fine, that's okay. So it is given to me 69 times, and this is needed to be divided by 7, and there I need to find the remainder, right, students? How do we do that? See, can you help me with this 62? So now you have two choices. What choices I'm talking about? What is 7 into 8? 7 into 8 is 56. 7 into 8 is 56. So 62 minus 56, what does it give me? 6. So with each of these 62, 62, 62, I'm getting 6 as a remainder. So 6 then is getting multiplied 69 times, and that won't help me much. What is our intent or motive? I'll try to find a multiple of 7 which is closer to 62, as close as possible. Even greater is also fine. Let me try and tell you why. Yeah. 7 into 9 is 63. But sir, 63 is greater than 62. Let us have it. 7 into 9 is 63. So when I divide 62 by 7, can I say the remainder is minus 1? Did you understand the part which I'm very, very, very abruptly or vaguely or confusingly saying, which might confuse you a lot here? That 62 when divided by 7 gives you a remainder minus 1. Why am I saying so? The logic is pretty simple. 7 into 9 is 63. So from 62, if 63 is subtracted, you get a remainder minus 1. Although technically the remainder is plus 6. But why can't we use it mathematically as minus 1? The concept of negative remainders in the theoretical world does not exist. But as per our need, we have created this. And let us use it here. And trust me, have faith in your teacher. It will be proven right, and it will help you in getting your answer more effectively and easily. And this is an extension of binomial theorem only, but in a different sense, but in a different manner. So let's use it here. So 7 into 9 is 63. 62 when divided by 7 gives you a remainder minus 1. Although 6, but in this world, let's enter into the world of negative remainders and let's say minus 1. So technically 62 by 7 gives you a remainder minus 1. So I've gotten a remainder minus 1 here. Same I'll receive from here, and these minus 1 I'll keep on receiving how many times? So these are the minus 1 getting multiplied 69 times. So these are getting multiplied how many times? 69 times. We all know if minus 1s are multiplied an odd number of times, I'll be getting minus 1 only. So ultimately, the remainder we have finally received is minus 1. But that's wrong. Mathematically or conceptually, it is wrong because the remainder can never be minus 1. That's what we know very clearly. What do I do next? I'll say that if negative remainders don't exist in your world, this negative remainder can be converted into a positive remainder. What was the divisor? 7. What is the remainder you have gotten? Minus 1. Add it to divisor. So the actual remainder will be the divisor or divisor, whatever you wish to call it, plus the negative remainder, and 7 minus 1 is going to be 6. This is going to be the actual divisor. The answer is pretty simple. 60 to the power 69. Whatever the actual number is going to be, which is impossible, humanly impossible to calculate, when divided by 7, will definitely give you a remainder 6. Did you understand this part? Did you understand this method? Are you getting a complete clarity on the remainder theorem, that instead of binomial theorem, you can use this particular approach, and through this short technique, through this short cut or short method, you can get the results. There are questions when you need to find the last digit, which is same as dividing a number by 10 and finding its remainder. Because what do you mean by last digit? See, if I were to ask you to find the last digit of a number, so let's say I am saying that 69 to the power anything, let's say 72 is given, and I'm asked to find its expansion's last digit. So there is a method that how can you find the last digit? There is a very standard method. If you start looking at the pattern, you can crack it. Other method could be, sir, whatever this number is going to be, I don't know, but in this number's expansion, if I divide it by 10, then the remainder will be its last digit. For example, let's say there is a number. There is a number 576. What is its last digit? 6. Can we calculate it through some other means? Yes. 576 when divided by 10, what does it say? What does it give you? Sir, 576 is nothing but what? 57 into 10 plus 6. So when you divide a number by 10 and see its remainder, then also you can calculate its last digit. I hope you're understanding the logic I'm trying to give you. So through that also, the last digits can be evaluated very easily. The other method is last digits have their own pattern. So instead of these two previous methods, either binomial or dividing a number by 10 and then finding its remainder, rather than using these two methods, which are a little lengthy in nature, I'm giving a third method, which is more efficient and effective. Let's say a question pops up and says that find the last digit of 69 raised to the power 782. Do you all not agree with this fact that, sir, whatever the last digit is going to be, it will be decided with the help of the unit digit of 69? So unit digit of the 69 will help us in deciding the last digit. What I'm trying to give you here is that what I am having here is 69, 69, 69, 69, 782 times is getting multiplied. So technically this 6 has no role to play at all in deciding the unit digits. The unit digit is getting decided with the help of the unit digit only. Please understand. Let's say I write 232 into 479 into 654. Now I need to find the unit digit. Do you really think that you need to find the entire product? Do you not think that, sir, it is absolutely unnecessary that you are dealing with this 2, 3, 4, 7 and 6, 5 here? Rather what you do is you do 4 into 9. So 4 into 9 is 36. Out of this 36, still again get rid of this 3. Just deal with its unit digit, which is 6. Now take this 6 into 2. 6 into 2 is 12. So final product is 12, out of which the unit digit is 2. So this entire product will have the unit digit as 2. That's what I'm trying to make you understand, that unit digit gets decided with the help of unit digit only. This is equally true in terms of addition and subtraction as well. And that's where I'm saying that if a question is asked on this particular category, that find the unit digit. Unit digit means the last digit in the expansion of this. Some of you may be lured to use binomial theorem. Please don't use that. Please don't use that. It is absolutely futile because it will consume a lot of time. You may end up wasting a lot of time because writing that whole expansion and all that will make you waste a lot of time. The second method also, where you are dividing it by 10 and then finding the remainder, that is also easier and more convenient than the first method, but still there is a third method which is very, very, very amazing. What is that? Let's learn it. I am asking you to look at the pattern of 9. What have we learned? What we have learned is that, sir, 9 is going to be the factor which will decide its unit digit. So let us observe or analyze 9. So what I'm trying to give you is, what will be 9 to the power 1? Sir, it is 9. What is 9 squared? Sir, it is 81. But what is its unit digit? Sir, 1. What is 9 cubes unit digit? Sir, 9 cubes unit digit will be 9 into 9 square unit digit. The unit digit in 9 square was 1. 1 into 9 is 9. So whatever 9 cube is going to be, I don't know that, but 9 cube will have its unit digit as 9, because 9 into 9 square is 9. I'm talking in a sense of unit digits. I repeat, what will be the unit digit of 9 to the power 4? You will say, sir, unit digit of 9 to the power 4 will be 9 into unit digit of 9 cube. So 9 into 9 is 81. 81 means the unit digit is 1. So I don't know what is going to be 9 to the power 4, but its unit digit will be 1. I am asking you to look at the pattern. Look at the pattern. This pattern will never go beyond a cycle of 4. You can see it for any unit digit, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So for this 9, for the number 9 at this unit digit's place, the cycle is restricted to 2 only. What I'm trying to make you understand is it is always 9, 1, 9, 1, 9, 1, 9, 1. So whenever you have the unit digit as 9, no matter what power you are raising it to, the unit digit is always going to be either 9 or 1, 9 or 1, 9 or 1, 9 or 1, and that too can be predicted. Whenever the power of this number is odd, the unit digit is 9. Whenever the power of this number is even, the unit digit is 1. Are you not seeing a pattern here? What I'm trying to make you understand is that here, this 9 has a power 2, which is even. And whenever the power is even, the unit digit is 1. So the answer is going to be 1. Do you really need to use a binomial theorem for this kind of questions? You don't. Let's take one more example so that you get more clarity on it, and then I think we can move ahead. For example, let's say here we have another question, which is, let's say 28 whole raised to the power 763. And the expansion of 28 to the power 763, we need to find the unit digit. Three methods are there. Let's skip first and second, move to the third, which is the easiest. How do I solve this particular category of questions? All I know is, sir, this 8, the unit digits place, the unit digits number will be the factor which will be deciding the unit digit. So let's deal with it. So rather than dealing with this question, I'm dealing with a question which is 8 to the power 763. Now, let us look at the pattern of 8. Let us look at the pattern of 8. What is 8 to the power 1? Sir, its unit digit will be 8. I'm writing the unit digit only, mind you everyone. What is 8 into 8? Sir, 8 into 8 is 64. The unit digit is 4. What is 8 cube? 8 cube will be 8 into 8 square. So 4 into 8, which is 32. So the unit digit is going to be 2. What is 8 to the power 4? 8 to the power 4 will be 8 into 8 cube. So 8 into 2. 8 into 2 is 16. The unit digit is going to be 6. I hope you're understanding. I'm not writing the complete number. I'm writing the unit digits only. Can you help me with 8 to the power 5? You will say 8 to the power 5 will be 8 into 8 to the power 4. So 8 into 6. 8 into 6 is 48. You have again gotten the unit digit as 8. I hope you can see the cycle has repeated again. So as I have already told you, for any digit 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, the cycle will never go beyond 4. You can see the cycle is 8426, again 8426, 8426, 8426. It will keep on happening. What does it mean? It means that whenever the cycle is first of all of 4, so whenever the power when divided by 4 gives you a remainder 1, the unit digit will be 8. The power when divided by 4 gives you a remainder 2, the unit digit will be 4. The power when divided by 4 gives you a remainder 3, then unit digit will be 2. The power, if it is a multiple of 4, which means if it is a remainder, when it is divided by 4 and if it gives a remainder 0, then the unit digit will be 6. So now all I need to focus upon is look at the power. Look at the power 763. I need to find its remainder when divided by 4. So I hope you know, whenever a number is divided by 4, to find its remainder, divide the last two digits of the number. So if I want to know what will be the remainder when 763 is divided by 4, I can use a technique of division, that last two digits of 763 are 63. So let's divide 63 by 4 and find the remainder. So when I divide 63 by 4 and find the remainder, I hope you all know very clearly that 4 basically divides it up to how many times? That number of times doesn't matter here. All I know is that up to 60, I think I'll be having a perfect division and I'll be left with 3 as a remainder. So remainder when 63 is divided by 4 is 3. How did I get it? Because I hope you know 15 into 4 is 60. So I'll be left with 3 here as a remainder. What does that mean? 8 to the power 763 could be simplified as 8 to the power 63 only, because the cycle was of 4. Because after every 4 powers, the same 8426 as a remainder, as a unit digit was getting repeated. Which means 8 to the power 63 can be simply be written as 8 cube, because 8 to the power 63 is what? 8 to the power 60 into 8 to the power 3, and 8 to the power 60 will fall into that loop of 4, 4, 4, 4 each. So what matters is what gets decided on the basis of what is going to be 8 cube only. And 8 cube has a unit factor 2 here. So this is giving me 2 at its unit digits place. Did you get this part? So 28 to the power 763 will have 2 as its unit digit number. Let's take one more example so that you understand it more clearly. Let's take one more example so that you stay assured with this particular result thoroughly. Let's take an example of, let's say, any number. Let's take any number. Which number do you want to take? Let's say 7, right? So let's say 287 whole raised to the power 592. This is the number, and we are asked to find its unit digit. How do we do it? I hope you understood the approach, that first of all, I need to find the cycle of 7. So for 7, we know 7 to the power 1 is 7. 7 square is 49, which is 9. I'm writing the unit digit only, right? What about 7 cube? 7 cube will be 7 into 9. 7 into 7 square. So 9 into 7 is 3. So the unit digit will be 3. Getting it? 7 to the power 4 will be 7 into 3. Unit digit. 7 into 3 is 21. So the unit digit will be 1. Did you get it? Now 1 into 7 will be 7 to the power 5 unit digits. So 7 to the power 5 is basically 1 into 7, which is 7. So again, the pattern is recurring after 4 powers. So again, the cycle is of 4. So here also I'll conclude that this question boils down to this question only, where I say that 7 to the power 92 is needed to be dealt with. Why? Because unit digit gets decided with the help of unit digit only. And 592 I need not look at. I now need to look at that what is the remainder I get when I divide 92 by 4, because 4 is the cycle I'm dealing with. So now the question is pretty simple. I now need to deal with what is the remainder I get when I divide 92 by 4. That also is something very easy to work upon, because 4 and 92, I hope you know, 96 is perfectly divisible, 88 is perfectly divisible, 92 is also perfectly divisible. This means the remainder is 0. Now, when the remainder is 0, you don't say that the answer is 7 to the power 0. When the remainder is 0, I hope you know that 92 is perfectly divisible by 4. So here I'll say that 7 will have a multiple of 4. 7 does have a power which is a multiple of 4. And if this power is a multiple of 4, and whenever the power is a multiple of 4, the remainder is 1. The remainder is 1. I hope you know that power is a multiple of 4. A 4k category of a power it is. So yes, in that case, I'm not saying the remainder, the unit digit is going to be 1. So whatever the expansion of 287 to the power 592 comes as, which I clearly can't evaluate, which we are not able to evaluate, humanly it is impossible, but that number, whatever number that is going to be, that number will have its unit digit as 1. If you could relate it with complex number, you will be able to understand it more clearly. I hope you know that in complex number, iota to the power 1 is 1, iota square is minus 1, iota cube is minus iota, and iota to the power 4 is 1. Now, if I ask you iota to the power 5, you will say iota. So iota also follows a cycle of 4. So if I ask you iota to the power 484, you will say, sir, don't look at it like this. 484 divided by 4 and look at the remainder. And that remainder should be raised as the iota's power, because iota follows a cycle of 4. So after 4 values, the values keeps on getting repeated. The same is true for unit digits. So with these digits 0 to 9, the unit digits are always same. The cyclicity is followed. Although for numbers, the cyclicity is not there, because if you look at 5, 5 to the power 1, 5, 5 square 5, 5 cube 5, 5 to the power 4 is 5. The unit digit is always 5. Even for 6, the cyclicity is 0, which means 1. 6 to the power 1 is 6, 6 square is 36, 6 cube is 216, so the unit digit is always 6. So you can classify these numbers and look at the pattern and look at the cyclicity and predict the unit digit with this much ease. You need not use the binomial theorem in such category of questions. Did you understand this part? Now, what do you do with the last 2 digits? I'll again share an example, and there I'll tell you how to do that. Of course, there is a shortcut here as well, but that shortcut is equally, lengthy in terms of this particular standard method where you can solve this category of questions through binomial. So when it was all about remainder in unit digits, I think the short methods, the short techniques which we have learned were more effective. But when it comes to dealing with the last 2 digits, this particular method, the standard binomial theorem expansion, is more efficient. How do we do that? Let's work on it. The particular question asked by JEE Mains in 2025, how do we solve it? It says the product of the last 2 digits is what they are asking. Let us work on finding the last 2 digits, then we'll do what is asked. Last 2 digits. Now, the base 1919. Can I write this 1919 as 1920 minus 1? That should be your motive. First of all, this is what you should do. That this number 1919 should be written as 1920 minus 1 or 1920 plus 1 or something like that. So here I could write 1919 as 1920 minus 1. That is what you should be able to do. Then only you will be able to find last 2 digits with a lot of ease. So if I'm able to write 1919 as 1920 minus 1, then I can expand it with the help of binomial theorem. I hope you understand binomial theorem. What does it say? As per the binomial theorem, the first term will be NC0. So 1, I'll write it first so that you see it happening, because then you won't be able to see a lot of things happening. Into 1920 to the power, difference of these two, which is 1919, into 1 to the power minus 1 to the power 0, which will be positive, minus the next term will be 1919 C1, then I'll have 1920 to the power difference of these two, which is 19 18, and minus 1 to the power 1 will be minus 1. And that's how you will keep going, right? Now, let's talk about few last terms. What about the last term, students? Can you help me with the last term? What is going to be the last term? So last term is going to be 1919C 1919 into 1920 to the power difference of these two, which is 0, minus 1 to the power 1919. So if it is minus 1 to the power 1919, can I simply not write it as minus of this here? Did you get this part? Before this, there would be a term which will be positive. What would that be? It would have been 1919C 1918 into 1920 to the power difference of these two, which is 1, and of course minus 1 to the power 1918 will be plus 1. So here it is appearing as plus 1. Let me write the third last term as well, so that I could tell you what is happening over here. Understand this particular process. It will help you in understanding it completely and clearly, that why am I doing all this. So the third last step would have been 1919C 1917. Of course, a minus sign will be there, plus minus alternatively turning up. And here I'll be writing it as 1920 to the power difference of these two, which is 2. Now I want you to observe this very minutely. Why am I saying this? Because please understand, now if you are paying attention to this part, 1920 to the power 1919, do you not think it will have 1919 zeros? Can you imagine this? Into something, then it will have 1918 number of zeros. I mean, there is a huge number which is followed by 1918 zeros. Then 19170. So many zeros are there in the end. So I hope you're realizing these terms won't contribute at all in deciding the last two digits. Are you getting my words? So when does the factor through which the last two term gets decided come into picture? Now look at the last three terms. Look at the last three terms. Even the third last term, 1920 to the power 2, what will it be? It will be 1920 into 1920. That means it will also have the last two terms as 0. So ultimately, I'll be getting a huge number so far, from this to this, when added, subtracted, and all this happens, I'll be getting a number which will have its last two digits as 0. Of course, a positive number, because this is greater than lesser, then greater than lesser. So effectively, it will be a positive number, and it is bound to be a positive number, because 1919 to the power 1919 is going to be a positive number. So nothing needs to be said about that, right? So here, so far, when I calculate this much part only, and if I try to make you imagine this part which I have written inside these yellow brackets, this will be a hugely great number, but it will have last two zeros here. It will have two zeros here in the end. I hope you are able to understand this particular part very clearly. But the remaining part, the rest of the number is going to be this minus this. What is it going to be? Let me talk about this particular number as well, this particular result. Now let's talk about this result. What is it? It is 1919C1918, which is 1919C1, which is 1919. I hope you are getting it. It is going to be 1919 into 1920. Okay. So first of all, it is going to be, let me write it here, 1919 into 1919 into 1920. I hope there is no confusion on it. Minus. What about this part here, students? I hope 1919C1919 is going to be 1. No confusions on that. Into 1. So this is 1 into 1, which is minus 1. So this is going to be minus 1 over here. I hope there is no confusion on it. So it is going to be minus 1 over here. I hope you're getting it very clearly. So now let's work on this result. So 1919 into 1920. I need not have this entire result over here. Even if I get the last two terms, that will be sufficient for me. But if you still want it, I can take the product of these two numbers. So I need to have the product of two numbers, 1919 and this other number, which is what? Which is clearly 1920. So 1919 and the next number is 1920. I'm just saving some time. It is going to be 3684480. Okay. So 3684480. I am not bothered about this, because basically I'm interested in the last two digits. So this product, what is it? Whatever it is going to be, let's work on the last two digits, and last two digits can be decided with the help of last two digits. So 19 into 20 will help me in cracking the last two digits, because 19 into 20 is basically 380. So the last two digits will be 80. So I need not deal with these other products as well. Minus 1, which will help me in getting 80 minus 1, which is 79. I am trying to make you understand a very, very simple conclusion, that this expression, whatever it is going to be, this pink covered region, whatever it is going to be, it will have its last two digits at 79. There could be some other digits which I'm not concerned about, but it will have its last two digits at 79. And that expression, which was there with the yellow brackets, that had its last two digits as two zeros. Although it will have some other numbers, but the last two digits will be two zeros. And from this and to this, I am basically, what I'm doing here is, I'm really sorry, this is positive, this is negative. So yes, it is going to be plus 79. I hope there is no confusion now. So basically, what you all need to understand is, this will be a positive number, this will be a positive number, and then when these two numbers are added, let me just check the signs here. This here was a completely positive number, this was a positive number, this was a negative number. So from this, if this was subtracted, 1 was subtracted from 80, so I think it was 79. So yes, it will also be a positive number. So to this number, if this number was added, whatever digits are there before this, I'm not concerned about that. But if the last two digits are added, I think the last two digits are going to be 79. Did you understand the whole process? How are we doing it? So whenever last two digits come into picture, the approach remains very simple. What you do is 1919. I write it as a difference of this kind of two numbers, where I write one of the numbers as 1 or minus 1 and the other number as a multiple of 10. That's what you're supposed to do. That's what you're supposed to manage somehow. And if you have done it through binomial expansion, you will see that only the last two terms will help you in getting or deciding the last two digits, which is eventually or logically or mathematically turning out to be as 79. So if the last two digits are turning out to be as 79, what were we asked? We were asked the product of the last two digits. The last two digits are 79, so the product of 7 and 9 is 63. So the product of the last two digits is 63. So there is again a catch. What students usually do is, in a rush, the moment they find the answer as 79, they mark the answer, they write the answer in the input box as 79 and move ahead by saving it. And that's the error. You were not asked the last two digits, you were asked the product of the last two digits. And that's again a catch. So you should be more cautious and alert and more attentive. So in a rush, once you have found the answer, you feel very happy, and all of a sudden, during, with this feeling of happiness, in a rush, you write 79 is the answer and move ahead and forget that product of 79 was asked, which was 63. So take care of it, that 63 would be the correct answer. Did you get this part? Did you understand this result? Let us move ahead towards the next part, where I'll be giving you more clarity that how do you deal with coefficients of binomial theorem. But before that, let's take clarity on multinomial theorem. This is what I'd like to put more clarity upon as far as multinomial theorem is considered. What I'm trying to make you understand is, yes, the way we had binomial, by means 2. So when two expressions were there and you were expanding it, you were raising it to a higher power, and there was a standard expansion we have learnt through binomial theorem. Similarly, there's a multinomial theorem. So instead of 2, there could be more terms, more than 2 terms, 3, 4, 5, 6, 7, 8, 9. So 3 are there, then it is called trinomial, and so on. So if such terms are given and if it is raised to a certain power, then also you can write it through a simple logic. Now, what is that logic? It is given by, please understand, summation of n factorial. What is n factorial? It is the power here, divided by alpha 1, alpha 2, alpha 3, alpha k factorials. All of them are used with their factorials. The product is done. What is alpha 1, alpha 2, alpha 3 and all? It is basically the powers these x1, x2, x3, xk are raised to. You must have gotten confused by this explanation. Now I'll be using a simpler method. What is that simpler method? The simpler method says that, let's say I'm expanding this result. I'll take a very simple example here. Let's say I'm expanding this result. What I'm expanding is x plus y plus z plus w. Let's say this is what I'm expanding. Let's say this is raised to the power 20. So it will have a lot of terms. The number of terms can also be calculated. We'll talk about that as well. But what I'm trying to make you understand here is a very simple result, that it will have a lot of terms. Of course, we cannot write all of its terms. We can generalize it. It will have a lot of terms, mind you, students. I'm just writing one of the terms. Let's say I'm asked a term where x is having power 3, y is having power 7, z is having power, let's say, 6, and w is having power 4. First of all, again, what you need to understand is x, y, z, and w, all these variables, the sum of the powers will be 20 only. It will always be 20. First of all, this is what you need to understand, that x, y, z, and w, these were the variables over here, these were the terms over here. So here, the sum of all of these powers, x, y, w, and z, they will have the sum as 20. It will always be 20 in each of the terms. So of course, there will be a lot of terms. I'm not going to write all those terms. I'm not able to write, but I'm giving you the idea that let's say there is a term which will have power of x as 3, power of y as 7, power of z as 6, and power of w as 4. Then can you write its coefficient? Yes. The coefficient says that if there is a term something like this, which has x1 has a certain power, x2 has a certain power, x3 has a certain power, xk has a certain power, then it is written as, its coefficient is written as summation of n factorial. What is n? It is 20 factorial divided by these powers individual factors. What is it? I hope you are realizing it very clearly. You have this. Of course, summation won't be there because summation was there to write all the possibilities here. But since we are talking about a specific case, so it will be 3 factorial into 7 factorial into 6 factorial into 4 factorial. When will I use summation? Because summation means all the possible combinations. For example, plus this, there could be other possibility. What is the possibility? Sir, what about x to the power 10, y to the power 1, z to the power 9, and w to the power 0? Can there be a term like this? Yes, there will be a term like this. What will be its coefficient? Sir, its coefficient will be 20 factorial divided by powers 10, 1, 9, and 0. Did you get that? So a lot of terms will get created. Number of terms is also something which we can evaluate very easily through our formula only. But here what I'm trying to make you understand is, since I'm not able to write all the terms here at this place, but with each term, let's say if I'm specified or given that this is the term, then I can talk about its coefficient through this formula. So first of all, multinomial theorem has its own expansion. And in that expansion, if I talk about each term and its coefficient, then this is how you write its coefficient. Did you get that part? Now, if you are able to digest this particular part, this is exactly what we are trying to give you here. What we are trying to make you understand is, look at this particular result. Look at this particular result. Here also you'll get this complete clarity. First of all, delta won't be there here in this case. So let me remove this delta from here. It will be alpha plus beta plus gamma only. Let me explain these two results here. Let us understand this particular multinomial theorem, which we have tried understanding here and here through this particular result. What is it? Let's say a plus b plus c to the power n, trinomial expansion. Through multinomial, let's expand it. It will have its own expansion, summation is there. But with each term, when you are using different powers of a, b, and c, of course, the sum of these powers will always be this n only. But this n factorial will be divided by alpha, beta, and gamma factorial, which are the powers of a, b, and c, where I need to ensure that sum of alpha, beta, and gamma will be the power only. This is exactly what I have explained here previously in the last slide. The same example they have illustrating here with the help of this. So summation sign is there to write summation as a possibility of all the possible powers of x, y, z, and w there. And the summation is there as an addition. So addition, then another possibility, then another possibility, then another possibility, and so on. In multinomial theorem, of course, you need to remember this expansion through this standard generalization. What is more important here is that whether you remember this or not, that sometimes in the questions, you may be asked that x plus y plus z plus w to the power 20 is given. And then you will be asked to write the coefficient of, let's say, the term having 3 power 3 as the power of x, 7 as the power of y, 6 as the power of z, and 4 as the power of w. Then you can simply write it, the coefficient, as 20 factorial upon 3 factorial, 7 factorial, 6 factorial, and 4 factorial. I hope you are understanding it. So this is something which you need to remember and learn. So I hope two things are very well understood and covered here in this particular case. One, the expansion of a multinomial expression. Second, how to find the coefficient if a certain term in variable sense is given. I hope these two things are very well understood. If you have gotten this part, let us talk about this particular part where you're asked the constant term in the expansion of this. So if you're expanding this, what will be the constant term? Now, you must realize it very clearly. If I'm asked about the constant term, What do you understand by this? Sir, if they are asking about the constant term, then the power of x must be 0. Are you getting it? The power of x must be 0. That conclusion can be used here. So if I write its generalized expansion, what would that be? Sir, that will be summation, of course, 5 factorial upon alpha factorial, beta factorial, gamma factorial, where what are alpha, beta and gamma? 2x to the power alpha, 1 upon x to the power 7 to the power beta, 3x squared to the power gamma. But now let's put our complete focus on this generalization here. I am wanting you all to understand that this expansion, this trinomial theorem's expansion will look like summation of 5 factorial upon something which I'll write later, 2x to the power alpha into 1 by x to the power 7 whole raised to the power beta into 3x square to the power gamma. Now, what will there be in the denominator? It will be alpha factorial into beta factorial into gamma factorial. Are you understanding this result here, students? Now, what am I asked? This summation means you keep trying different values of alpha, beta and gamma. Where you all need to understand is that for these different natural numbers, whole numbers of alpha and beta and gamma, the sum should always be 5. So sometimes it could be 500, sometimes it could be 050, sometimes it could be 005, or it could be 311, or it could be 221, and all lot other possibilities like that. What is our concern? Our concern is to ensure that I could find the constant terms in this expansion. So when somebody says that you need to deal with the constant terms, what am I asking is that the power of x cumulatively should be 0. If the power of x is 0, that's the possibility, or those are the possible terms which are the constant terms, because there is no x. I hope you're getting it. So let's try and find that constant term x here. I hope you're able to digest this particular part. Let's work on finding the constant term. So one conclusion we are able to draw from here. So basically two conclusions we'll be drawing. First conclusion is this, that alpha plus beta plus gamma should be 5. What about the other conclusion? Let's look at the powers of x. Let's try and evaluate this result, right? So if I simplify the powers of x, what are going to be the powers of x? Let's work on that. Let me rewrite this general term, right? So the general term we are having summation, of course, because all the other terms are also going to be there. It is going to be 5 factorial divided by, of course, alpha factorial, beta factorial, and gamma factorial, which are going to be there. But let's write it. So 2 to the power alpha will be there, 3 to the power gamma will be there. Okay, let me write this part as well. So I'll have into 2 to the power alpha into 3 to the power gamma. This will be there. I hope there is no doubt on it. Now, to this, what I have is x to the power alpha. I hope you can see it. X to the power alpha. Then from here, I'll have x to the power minus 7 beta in the numerator. So it is going to be minus 7 beta. And then x to the power 2 gamma. I hope it is perfectly understandable. It is x to the power 2 gamma means this plus 2 gamma. Everyone with me on this? Now, what is the conclusion we have drawn? We have been able to draw from here. I hope this part is very well understood by you all, that it is x to the power alpha, x to the power minus 7 beta, and x to the power 2 gamma. I hope there is no confusion in it. So x, y, z, sorry, alpha, beta, gamma are going to be some integral values. But here, another challenge is that we want the term to be constant term. Now the term is constant, there should be no x, which means the power of x should be 0. Very understandable, very much understandable. So from here, I can draw one more conclusion, that alpha minus 7 beta plus 2 gamma should be 0. Did you understand this part? And along with this, we have this result, alpha plus beta plus gamma should be 5. So alpha plus beta plus gamma should be 5. Now, one thing we all are very clearly able to understand is that now what result do we use? What result should be used? From here, shall I not say that 7 beta can be written as alpha plus 2 gamma? So that is the result which I'll be using, that alpha plus 2 gamma should be 7 beta. That will be more comfortable for me to look at, because I put the values here and then I check them here. So rather than this and this is what I'll be using. So I'll be highlighting these two results, which I'll be using here in these two cases. So this result and these two results. I'll try and find the triplets of alpha, beta and gamma with the help of these two results. Everyone comfortable with this? Now, I hope you all are able to understand. Let's say a very simple data set I take. Let's say 1, 2, 2. Let's try and check with some values, then we'll be able to generalize a pattern. So let me say that I have taken alpha, beta and gamma as 1, 2, 2. What is the challenge here? So 1, 2, 2 is 5. That is perfectly acceptable. But what is the challenge here? Alpha is 1, gamma is 2. So 2 into 2 is 4. 4 plus 1 is 5. And beta is already 2. And 2 into 7 will be amazingly huge. So do you see the challenge here? I just tried giving you an example that here I need to keep beta as low as small as possible because this beta is already getting multiplied to 7. So alpha and gamma don't have much huge or higher choices. I hope you can realize and see and understand it clearly happening over here. So what I need to understand is that beta should be as low as possible. So I'll try to keep beta 1 for a while. Let's say we are keeping beta as 1. So this is alpha, let's say, or rather I'll write it here. So all the possible cases I'm writing here alpha, beta and gamma, right? So I'm beginning with the value of beta as 1. Can I begin with that? So if I keep beta as 1, it is going to be 7, which is going to be alpha plus 2 gamma. Now, is there any possibility through which I can, make it 7? So let's try and think in terms of alpha and gamma. So if I simply take, now here you need to calculate, you need to do some guesswork, right? So if I take alpha as 6, which we cannot because alpha plus beta gamma should be 5. That I cannot because alpha should be less than 5. Alpha, beta, gamma, all of them should be less than 5 and greater than equal to 0. I hope you're getting it. So 7, which is an odd number, and from here it will be an even plus odd. It will be even plus odd, which I think is only possibility. One of the possibilities 6 plus 1. I hope you're getting it. So C, for 6, it should be 3 and it should be 1. So I think I have gotten a conclusion that if I keep alpha as 1 and gamma as 3, that's a possibility. Why? I hope you can see it very clearly here that if I keep alpha, beta, gamma as 1, 1, 3. So I hope you can see 1, 6, 7. I hope you see it here. And 1, 1, 3, we all know is going to be 5 because I have ensured that the sum should also stay 5. So if I took this as 3, it should be 1 because the other one was already used by alpha or rather beta. I hope this possibility is very well understood by you all. Second possibility. I hope for this beta, which was 1 here, I had only one possibility that alpha is 1, gamma is 3 because the other possibility could not be evaluated. I hope you're understanding why. Second possibility, let's try to keep beta 2 because beta is that number which is 7 beta. Here in the LHS of this, it is 7 beta. So that gives me a lot of flexibility that I can shorten, I can narrow down my possibilities because 7 beta is going to be amazingly huge. So I can cut short a lot of results with this particular conclusion. I hope you're understanding. This LHS is going to be very helpful for us. So if I try beta as 2, let's say I'm trying beta as 2. So 7 beta is going to be 14. So now I want this sum to be 14. And this sum 14 is amazingly huge number because to make it even 14, which is even, I should have two great or huge numbers here. So even if I take a huge number, 14 cannot be made. I hope you're realizing. Because to make a 14 here, even if I split it into something like 6 and 8, the biggest possible case, then alpha will be 6 and gamma will be 4, which is not possible because 6 plus 4 plus 2 will be huge, which will cross this condition. So when I try and put it like this, beta is not possible as 2. And rather than 2, 3, 4, 5 is also not possible for it. And beta we cannot keep 0 because if I keep beta 0, alpha will be equal to minus 2 gamma. And we know that gamma is a positive number. Alpha cannot be a negative number. So that possibility is also discarded. So the only possibility we are left with 1, 1, 3. So we have cracked the value of alpha, beta, gamma. So no summation is there. Only one term will be constant term, which will have alpha as 1, beta as 1 and gamma as 3. Did you get this part? So if I have cracked, I think this will become x to the power 0, which will be 1. And this will be the constant term because there will be no summation. This is the only term. Are you getting this part? So this will be my answer. All I need to do is put the values of alpha and gamma here. I hope you have understood how did I calculate this part. So I think we can write the answer here only. 5 factorial into 2 to the power alpha. What is 2 to the power alpha? 2 to the power alpha is 2 to the power 1, which is 2 into 3 to the power gamma is 3 to the power gamma is 3 to the power 3, which is 3 cube divided by what, students? Divided by alpha factorial, beta factorial, gamma factorial, which is nothing but what? 1 factorial into 1 factorial into 3 factorial. So I now leave it up to you that you decide the answer, which is something really simple and easy because 5 factorial is going to be 5 into 4 into 3 factorial. So this 3 factorial gets cancelled and from here I'm left with 5 into 4. So I think we have the conclusion now, because what is that going to be? 5 into 4 is 20, 20 into 2 is 40. I hope we are left with nothing else. So I repeat, 5 into 4 is 20, 20 into 2 is 40, and 40 into 3 cube is basically 27. This is what we need to do. I hope that part is very well understood by you all. There is no confusion on it. I believe so. I think we can write the answer finally. So 4 times of 27, double of 27 is I think 54. I think, and 54 doubled when gives you 108. Yes, so 108 into 108 followed by a 0 will be 1080, and that will be the answer to this question. Did you get this part? Did you get this part? That the constant term in the expansion of this will be 1080. Tricky it was. What sense? If you know how to write the general term in a multinomial expansion, then the only tricky part was that how do you decide that the term is a constant term? Second part, if the term is a constant term, there will be power of x is 0. So there we had two equations in alpha, beta and gamma. But there was this constraint that alpha, beta, gamma will lie between 0 and 5. They'll be natural numbers or rather whole numbers. And with these three constraints, this, and alpha, beta should lie between 0 and 5. There we could find only one case satisfying this possibility. And through that, we could find the constant term. Did you get that part? Are you understanding how to use or solve questions based on multinomial theorem? Now let's move to the part where we discuss the number of distinct terms. The idea is very simple here, students. The number of distinct terms are always given by, let's say, here are certain number of terms. Let's say there I'm having k terms, and the power is n. This is the power, right? So the number of distinct terms a multinomial expansion will have. I hope you remember we had a discussion on this, that we'll discuss it later. That's exactly where we are discussing it. So the number of terms in its expansion will be n plus k minus 1 ck minus 1. The proof is really simple. As of now, let's learn the formula directly. And if I were to give you an example, how do you decide it? For example, let's say this is a trinomial expansion. What is it? X plus y plus z. Let's say it is raised to the power 10. Now, if I ask you the number of dissimilar terms, number of distinct terms in the expansion of this trinomial expansion, what will be your answer? Your answer will be, sir, what will be the value of n? So this 10 over here is your n. How do you decide k? The number of terms. So k is over here 3. So what is the formula? N plus k minus 1 ck minus 1. So what is it going to be? 10 plus 3 minus 1 c 3 minus 1. What is it going to be? 13 minus 1, which is 12 c2. So there will be 12 c2 number of distinct dissimilar terms in the expansion of x plus y plus z whole raised to the power 10. Did you get that part? It is simply as that how many ways can you distribute 10 identical objects among 3 people? It is that only. This is exactly what we'll discuss in PNC as well. And that's where I'll be giving you more clarity about its proof. So don't worry about that result. We'll definitely have a discussion on this. And yes, there is another thing which is known as greatest coefficient multinomial expansion. So what we usually do is, what we usually feel or what we usually face is that sometimes we have to find the greatest coefficient multinomial expansion as well. I hope you remember, for a binomial expansion, we have learnt a formula. Similarly, there is a standard formula which you need to learn and apply it whenever you're asked. Although not very frequently it is asked, but still you should remember this as a formula. I'll directly give you the formula. The formula is that if you are given a multinomial expansion, something like this, I hope you are very much used to with this now, that x1 plus x2 plus x3 up till xn raised to the power n. And this expansion will have a lot of terms, as we have discussed, n plus k minus 1 ck minus 1. In that expansion, if I'm asked what will be the greatest term, greatest coefficient, then it will be given by n factorial divided by, I hope you remember, alpha factorial, beta factorial, gamma factorial. That is what we have been discussing. Here what you need to understand is that those powers should be equally divided. Those powers should be equally divided. What I'm trying to make you understand is, please understand a very simple result. Let me take an example. Let's say I am asked to find the greatest coefficient in the expansion of a plus b plus c to the power 10. Now I'll give you a very simple idea here. How many terms are there? 3. What is the power here? 10. So divide this 10 by 3. I repeat, divide this 10 by 3. What do you get? Sir, 10 basically, okay, I'll write it like this only so that you get it more clearly. 10 when divided by 3 gives you the remainder 1 and the quotient as 3. Now this remainder and quotient are very helpful for us. Because what I'm trying to make you understand is that this power 10 can be written as groups of 3. So 3 groups of 3 plus 1 group of 1. I repeat, 3 into 3 is 9 and 1 into 1 is 1. So I could create 3 equal groups of 3 and 1 group of 1. So divide your power into such number of groups. The groups will be decided by number of terms here. A plus B plus C, 3 terms were there. So I needed to make 3 groups in such a manner that I could distribute this power over here like this. I hope there is no confusion on that. Now, let us move ahead. Let us move further. What do we have here? A plus B plus C whole raised to the power 10. How do I deal with this part further? I need to write the greatest coefficient. The greatest coefficient will be nothing but n factorial, which is going to be 10 factorial, whole divided by q factorial. What is q here? Q is going to be your 3. So 3 factorial raised to the power n k minus r. What is k minus r? K was 3, r is 1. So the remaining groups. I hope you're getting it very clearly. So here 3 factorial is given to those two parts and that remaining part. Which part, students? Q plus 1. What is q plus 1? This is 3 plus 1, which is 4. 4 is given to, or rather 4 factorial is given to this other remaining part, which was only one part. I repeat my part very clearly here, students, that 10 we have split it as 3 plus 3 and this one 4. Because 10 we were supposed to split between A, B and C, because A, B and C would have had those powers. So I tried distributing 10 in such a manner that these values were as close as possible. So first of all, I tried dividing 10. So when I divided 10 in these three parts, those two parts were equal 3, 3. But the rest of the remainder, which was what? 1, was added to that other 3 and made it 4. I hope you are understanding the relevance of this formula. So this will be that largest coefficient. All the other values, 10 factorial upon all the other combinations which you will try for alpha, beta and gamma will give you the lesser number of values. I hope you are able to understand this logic along with this formula. Even if you don't remember this formula, remember this logic. That is more helpful and more convenient for you if you use it in the exam. Okay, so let us move ahead with the next part where we discuss a question, and this is the third most important category of questions from where questions are asked. Of course, we had a discussion binomial theorem, then we had a discussion binomial coefficient, and this is an extension of that only, that they are doing some practicals, some experimentations with binomial coefficient. So you write a binomial expression 1 plus x to the power n, its expansion, and then you do some experimentations like you either multiply it with x, you divide it by x, or you differentiate it and then you integrate it, and a lot of operations can be done, a lot of things can be done. There is a complete series of operations can be done. But now when we solve such category of questions, by observing this, you're supposed to work out that what can be done through which you can actually figure out its value. Here, if I pay attention to this part, what am I seeing here is 20C4, then 20C5, then 20C6, 20C7, 20C20. So what is it making us understand is that something raised to the power 20 will be needed to be done. And whenever this something comes into picture, let us think of it in this manner, that we'll talk about 1 plus x to the power 20 or 1 minus x to the power 20. One more thing has come into picture. Sir, 1 plus x or 1 minus x? So I think I am seeing alternatively this plus minus sign. So instead of 1 plus x, why can't or why should we not take 1 minus x? So I'll be writing 1 minus x to the power 20 over here. I hope there is no confusion on it. So 1 minus x to the power 20, when written over here, when you take it, I hope there is some clarity here so far, but still there is some confusion, sir. It is not 20C0, 20C1, 20C2. It is starting with 20C4. Okay, we'll talk about that later. We'll work out that later. But as of now, can we deal with this part? Can we first write this part so that we can build some approach and then we may think of doing something? So first of all, I am getting this idea that 1 minus x to the power 20 could be helpful. Two reasons are there. Which two reasons? First reason, 20C4, 20C5, 20C6, that was given, and plus minus was alternatively there. So if that was the scenario, I'll very clearly say that 1 minus x to the power 20 could be useful. If it is not, we'll remove it, we'll use something else. But as of now, it looks helpful. Now, after writing the expansion of 1 minus x to the power 20, what will I do? That we'll discuss later. But first of all, let us write and let us work out what is needed to be done. And that you will be able to predict only once you have written this expansion. So I hope that expansion is simple because I'll begin with 20C0. Of course, here we know this very clearly. 1, no matter what power it is raised to, will remain 1 only. But minus x to the power 0 will not matter at all. Then I'll have minus 20C1 x to the power 1 plus 20C2 x square, because we know whenever x is having an even power, it will be positive, and whenever x is having an odd power, it will be negative. So 20C2, then what will I have? Minus, what is happening here? Just give me a second. 20C2 x square minus 20C3 x cube and so on up till, I need it up till 20C4, right? Okay, so let me write it first. Up till what? Up till 20C20 x to the power 20. So this is going to be the result we'll be dealing with. Are you comfortably understanding it? But sir, there is a problem that here you are not having this expression in terms of 20C4, 20C5, 20C6. It is beginning with 20C0. How do you deal with this particular part? Okay, let us try and now understand what do we have here. Sir, with this 20C1 here, let me put your focus here on this part. With this 20C4, I had 2, 1. With 20C5, I had 3 into 2. With 20C6, I had 4 into 3. With 20C7, I had 5 into 4. So numbers are consecutive. For example, 2 into 1, 3 into 2, 4 into 3, 5 into 4. So something can be done, but what could be that something? Let's start working on it. Now, here comes differentiation or integration comes into picture, because if you use the concept of differentiation or integration or successive differentiation or successive integration, you may get numbers like this 18 into 17. Because please try and understand. What I'm trying to make you understand is, let's say I have x to the power 19 somewhere. And if I differentiate it, I'll get 19 into x to the power 18. And if I redifferentiate it, I'll get 19 into 18 into x to the power 17. So I hope you're realizing there is a possibility to create these results through differentiation possibly. But before I differentiate, I should put my more focus on this thing, that from which term onward do I need this? So 2 into 1 is there, 3 into 2 is there, 4 into 3 is there. So I need to work out that from which term do I need to do this and how will I achieve it? That's my motive or that's my intent. So how should we do it? So there is a standard method, there is a standard technique. Let us first of all divide this whole expression by x square. Now why did I divide it by x square only? X square I deliberately introduced because there were two terms. Which two terms? 2, 1, 3, 2, 4, 3, 5, 4. That's why we are introducing this x square. So I'm dividing both the sides by x square. Another reason of introducing x square, because I wanted or I needed terms from 20C4. I needed terms from 20C4. There I will need help from x square. How? Let me try and write it here. So I'm dividing both the sides by x square in this particular part. So if I divide both the sides by x square, I'll write it separately because I need to do this thing here. So I'll write 1 minus x whole raised to the power 20 divided by x square on the left hand side. I hope this part is very well understood by you all. Here it will be 20C0. We all know is nothing but what? It is clearly 1. So it is going to be 1 by x square. Then what do we have? 20C1. It is clearly going to be nothing but what? 20. I hope you're understanding it. So it is going to be 20 x upon x square, which is going to be 20 upon x. I hope this part is making complete sense here. Now, look at this part 20C2. So 20C2 I'm writing as 20C2 only. I'm not expanding it further. But here, when you divide it by x square, you're left with 20C2 only. So that's the constant term you're left with, 20C2. Are you getting this part clearly? Now, let us move ahead. Now you'll start realizing why did we do it. Minus 20C3 x cube upon x square will leave me with 20C3x. Did you get this part? Then what will I get next? I'll get next as 20C4. I'll get next as 20C4 into x square. Did you get this part? Why did I do it? Now are you able to make some sense out of it? Again, it is more about connecting the dots, especially in this category of questions, where you need to look at the pattern and then some certain arrangements, some playing with the binomial theorem is needed to be done. And with that experimentation, you come to this particular result. Although it's little tricky to predict such conclusions. So there is a set of rules which you follow. Sometimes you differentiate, sometimes you integrate. For example, this is a classic example of differentiation. Similarly, there is an example through which we'll understand to solve or solving this category of questions through integration. But that is a different case, that is a different category. There I'll try and tell you that why did we differentiate it here and why are we integrating it there through that example, which we'll discuss later. But as of now, Let us look at this result. So it is going to be 20c4x square. Then of course I'll have minus 20c5 x cube. I hope you are getting it very clearly. And so on until the last term is attained, which will be 20c20 x to the power 18. I hope there is no confusion on it. You are able to digest this whole result where I have done nothing, but I have divided both the sides by x square very clearly. I hope you are able to digest this part. Now what I do next is, can we basically differentiate this once? So if I differentiate it once, what result or what conclusion will I be getting and what will be the advantage of this? Okay, let us first differentiate it. So what do I get by differentiating it? The problematic part will be differentiating this, which is not a tough challenge. You know how to differentiate it. But sir, why are you saying that differentiation is needed to be done? Because if you start looking at this part, you will come to the conclusion that yes, differentiation is very helpful. Let me try and suggest you that, or let me try and show you that. 20c0, constant term differentiation will be 0. 20c3 into x, something constant because derivative of x will be 1, 20c3, that constant I'll get, which I can deal with later. But here, 20c4 x square, what is x square? Sir, differentiation of x square will be 2x. I hope you're getting it. Here, 20c5 x cube, so differentiation of 20c5 x cube will be 3 into x square into 20c5. Are you understanding this part? So this thing here is going to play a very crucial role, because there you need to understand, sir, differentiation once will not help me at all, because 5 into 4, 18 into 17, two terms in each coefficient, with each coefficient is given. So if you differentiate it once, you will get 2 into x. Here you will get 3 into x square. But what I need is 3 into 2 into something. So are you not realizing I need to differentiate it twice? So that's where, first of all, you need to understand that this entire expression is needed to be differentiated twice. Are you able to understand or digest this particular result? That how was I able to conclude that this expression is needed to be differentiated twice? I hope you're getting this result very clearly. So I'll differentiate this part first, and then I'll differentiate this part. And then again, I'll redifferentiate the whole result. That is a little cumbersome process, and that is a little more time taking, but that is what you're supposed to do. You cannot skip this. So this part on the left hand side, 1 minus x to the power 20 upon x square. I am going to differentiate this particular result, 1 minus x to the power 20 upon x square. Right, this is the result. We are running short of the space here, some space here, so I'll be using it here. 1 minus x to the power 20 upon x square. Can I write that result as 1 minus x whole raised to the power 20 into x to the power minus 2? So instead of using the quotient rule, I'll be using the product rule, because it will be more helpful. Anyways, it will be same. It won't matter. It will give you the same result, but yes, it will be more helpful. Why? Because here, if I use the product rule, so first function, so derivative of first function 1 minus x to the power 20, it will be 20, 1 minus x to the power 19, and then derivative, as per the chain rule, the derivative of 1 minus x will be minus 1. I hope there is no confusion on it. I repeat, first function, derivative of first function will be 20, 1 minus x to the power 19. As per the chain rule, I need to differentiate 1 minus x now, which will be minus 1. And second function as it is, which is x to the power minus 2. I hope you are comfortably understanding this. Plus, the next result will be differentiating the second function. Second function is x to the power minus 2. So differentiation of it will be, differentiation of x to the power minus 2 will be minus 2 x to the power minus 3. So I'll write it like this only. And first function as it is. What is the first function? That is, sorry, it should be minus 2 here. So I forgot writing minus 2. Just give me a second. Minus 2 x to the power minus 3. And then you need to write 1 minus x to the power 1 minus x to the power 20. Second function as it is. First function as it is. I repeat, derivative of first function into second function plus derivative of second function into first function. Did you get this part? Yeah. This is the conclusion we have drawn here. Now, what about the next part? So next part is differentiating the right hand side. I hope there is no confusion on it. So here I'll be differentiating the right hand side. So let us now differentiate the right hand side. The derivative of right hand side, 1 by x square. I hope you are understanding x to the power minus 2. So it is going to be minus 2 x to the power minus 3. I hope you are understanding it. So minus 2 x to the power minus 3. Then proceeding ahead, what do we have? Minus 20 upon x. So it is minus 20 into x to the power minus 1. So it is going to be plus 20 upon x square, or plus 20 into x to the power minus 2. So plus 20 x to the power minus 2. I hope you are comfortably understanding this result. Now, 20c3 into x. So this will be 20c3. Here, this is more important. So I'm writing this part here. I'll be writing this part here. I hope no confusion is there. 20c3 with a negative sign. So differentiation of this will be 20c3. X will become 1 when differentiated. Next will be 20c4 into x square. So it should be 2. It should be 2. What is happening? 2. What's wrong with this? 2 into 20c4 and x, I believe. Let me just check it again. 20c4 x square 2 into 20c4x minus. Next result was 20c5x cube. So it will be 3 into 20c5x square. I hope I'm writing it correctly. 3 20c5x square and so on until the last term is achieved. Now, I am asking you to redifferentiate. Do it one more time and then you'll see your result happening over or coming over there in front of you. Now, if I differentiate this, yes, it is becoming more cumbersome, more lengthy in terms of calculation, but this is what you're supposed to do. This cannot be avoided. So here, if I differentiate this result, what do I get? Anyways, if I convert it into a quotient rule, then also I would have had to put some same number of efforts. So I think let's go with this process here. So I'm applying differentiation. I'm differentiating this part and then this part. I hope it is not becoming more confusing at all. I hope you're able to understand this result here. So this when differentiated gives you minus 20 stays outside. And I'll be differentiating this result here, which I'm writing separately so that you don't get confused. 1 minus x to the power 19 into x to the power minus 2, right? Minus 2 I'm keeping outside ddx of this part, which is x to the power minus 3 into, or rather, even if I take common, I'll have to put some same number of efforts. So let's do it here. X to the power minus 3 and 1 minus x to the power 20. I hope this is understandable. And there, what I do is I redifferentiate it. So what I get is minus 3 into minus 2, which is going to be 6, and x to the power minus 4. So I'll write it like this only, x to the power minus 4 plus. Instead of plus, it should be minus. So it should be minus 40 x to the power minus 3, right? This constant becomes 0 when differentiated. Now this becomes 2 into 1. So now is the moment for which we have been putting efforts upon. This is the moment. See, 2 into 1 into 20c4 minus 3 into 2, 20, let me write it more clearly, 3 into 2 into 20c5. And now you will start see things happening over here. Of course, with an x, which is not a problem at all, because now you will see that what we were expecting, 2 into 1, 20c4. Are you seeing 2 into 1, 20c4? Then minus 3 into 2, 20c5. So minus 3 into 2, 20c5. That has started happening. Now, I now leave it up to you that you do it by yourself. All you need to do is, sir, here we did not need x. The next term will be there in x square. So that x we don't need. So what do? You can differentiate it by yourself, which you know how to by using simple chain rule and product rule. And here, in place of all these x, ultimately after differentiating this left-hand side, you need to replace x by 1. So when you do so, from here until end will be nothing but what? The expression whose value is what you're asked in the question. And when you differentiate this result and then you replace x by 1, from that, when you subtract this expression, when you replace x by 1 will be your answer, because this is exactly what you're asked in the question. And this minus this will be the answer to the question. So next step involves two things. Differentiation of the left hand side and then replacing x by 1, and that will give you the answer. Tricky, lengthy, exhaustive it was. I totally accept it. Sir, should we attempt such questions in the first go? No, simply avoid them. They are moderate to difficulty level of questions, moderate to hard category of questions. So yes, once you have done all the easy, even the moderate ones which you felt doable, then move to such category of questions. But yes, there are certain questions based on the series of binomial coefficients. If they are very easily doable, if you feel that yes, this much efforts would not be required, then go ahead with them. Second question, the next question will be a bonus question. This is a question which requires integration. Now, How do we do it? This is basically a question which is going to be the assignment question. Although, before I give this question to you, three things as hints I wish to give you, so that when you do it or attempt it, then you write your answers in the chat box and I'll be lovingly waiting for your responses. My first hint will be expand this summation. So once you expand this summation, put the value of r as 0 first. What will it be? So it will be 11c0 plus 1, which is 11c1 divided by 2r plus 2, which is basically 2. I hope there is no confusion on it. Then sum. Next will be put r as 1. So it will be basically these are odd numbers and that is next even number. So it is 11c. I hope you can see it very clearly. When r is replaced by 1, it will be 3. So it is 11c3 and it will be what? 2 plus 2. So that is 4. So I hope you have seen the pattern. The next term will be 11c5 and divided by 6 and so on until the last term. So one of the methods is that, sir, instead of integration, we'll put a lot of efforts. Why should we not simply find 11c1, 11c3, 11c5? Next term, next two terms will be what? Next term will be 11. Next term will be 11 c7 by, of course, 8. And then you'll have 11 c9 divided by 10. And the last term will be 11 c11 divided by 12. If somebody says, sir, I'll find 11c1, 11c3, 11c5, 11c7, 11c9, 11c11, put those values and get the answer, yes, do it. Nothing wrong in that. The efforts which you'll put in calculating this will be same as what I'll be asking you to do next. So what is the next step? The next step is pretty simple here, students. The next step is, since you are dealing with 11c1, 11c3, 11c5, what you must have noticed is that I need to deal with either 1 plus x to the power 11 or 1 minus x to the power 11. So the second hint number 2 is write 1 plus x to the power 11. The second hint for you is write the expansion of 1 plus x to the power 11. Through that, you can very easily move towards the next part of this particular question. The two next hints would be simply this, that integrate this expansion. You will get something in the RHS. I hope you know it. The expansion will be very simple, 11c0 x to the power 0 plus 11c1 x to the power 1 and then so on up till the last term. The second hint is integrate both the sides from 0 to 1 with respect to x. I repeat, integrate both sides from 0 to 1 with respect to x. Did you get this part? So when you are integrating, you'll get something really simple and easy. And then integrate the same result from -1 to 0 with respect to x. I repeat, this particular equation on both the sides, when integrated, definite integration is needed to be done from 0 to 1 as limits. With respect to x, you'll get a result. Similarly, from -1 to 0 with respect to x as a result. And these two results, let's call them equation 1 and let's call them equation 2. So if these two equations from equation 1 and from equation 2, if you subtract, what you will notice it that the identical terms will be the terms with the odd coefficient. So 11c2, 11c4, 11c6, 11c8, 11c10, they'll be getting cancelled, and then you'll get double of what you are asked. And I hope after subtraction, the same process will be done on the left hand side as well. You will get your final answer. I haven't given you the solution completely, but I have given you the hint that such questions can be done through this method if they are easily calculated. But if they cannot be easily calculated, you can do integration as well, the way we differentiate it. So this is a question where integration is required. Did you understand this part? I hope. Binomial theorem, majorly in a sense that binomial expansion, coefficients, operations, and then series. All of it is very well understood by you all, along with multinomial theorem and all. Mostly, the first part of this video was more crucial, and then the second part of this video. The last part of the video is of course doable, but it is lengthy in nature because there you need to do two things. First of all, predict what is needed to be done. There are cases, there are methods which you need to do, and there you need to think a lot. And second, they involve a lot of calculation, as you must have seen. So I'll say, if you are putting your efforts in this chapter, which is of course a very crucial one, put your focus in the first and second part of this video. Third part contains lesser amount of weightage in terms of ROI, because the efforts you will be putting here in the third part will not be as equal or as efficient as in terms of the result you will be gaining in the end. So I hope this is understood by you all. And I hope you know that Elevate JEE crash course, Elevate JEE crash course is an initiative started by us. It is an absolutely free of course, free of cost course, which we have started with these one-shot videos of these different chapters altogether with a very comprehensive and detailed knowledge we are trying to give in these lectures at absolutely no cost. Along with these videos, we are also providing you the DPPs and these handwritten notes as well. These DPPs and handwritten notes can be accessed by you all by clicking on a link given in the description. It will redirect you to our app from where you can access all of this at absolutely no cost. The PW app is an amazing platform from where millions of students are already preparing for different competitive exams. So I think this is enough for the day. Let's call it a day here. Let's meet in the next video. Thank you so much. You have been a great audience.